Bengaluru, that counts as the third top startup city across the globe, opens up a new and exciting opportunity for all innovators to come on board at the Dayananda Sagar University. Founded by late Sri R. Dayananda Sagar and late Dr. Chandrama Sagar, Dayananda Sagar Institutions is into education and healthcare for over 6 decades. DSI is today considered a center of excellence in producing students with exceptional academic skills and leadership qualities. DSI is now headed by Dr. D. Hemachandra Sagar and Dr. D. Premachandra Sagar. This leadership has successfully managed and excelled in ensuring excellence in all of its offerings. This great foundation ensured DSI to be invited by the Karnataka state government to set up a private university in the state. DSU could be among the very few campuses in the country to have a well-planned startup village that houses innovation labs supported by industry leaders. DSU provides a platform to visionaries and inventors to experiment their ideas. Globally reputed MNCs that include Autodesk, Bosch Etas, IBM, GE, VMware, NVIDIA and Boston, Bosch Rexroth, Dassault Systems are now part of the DSU initiatives. These companies have invested vast resources to create a one-of-its-kind facility to be used by the community. Joining this great movement is the support from industry bodies, Indian Electronics and Semiconductors Association, Manufacturers Association of India, and Indian Institute of Science in Bengaluru. The Startup Village will now receive guidance from Arizona State University, Rochester Institute of Technology, and Illinois Institute of Technology, Chicago. With a reputation for innovation, are strong backers of the DSU initiatives. Distinguished individuals from industry, academics, research, government are lined up to mentor each of the entrepreneurial ideas to ensure all good ideas meet with success. A bouquet of specialists on call, patent lawyers to accountants, costing and taxation specialists, company secretaries, procurement engineers, bankers, designers, packaging specialists, logistics experts is one more feature of the DSU campus. Every year, groups of individuals enter the DSU portals with a burning passion and a dream to achieve. With the combined support and resources at their command, they are now sure to walk out of the DSU campus as owners of the companies enlisted on the National Stock Exchange and a university degree. The ecosystem created by DSU can now accommodate 300 enterprises and welcomes the community to take advantage of this great option and work towards making India a strong manufacturing nation. For passionate and innovative youth, Bengaluru is the place to be. And presenting
Dayananda Sagar University. Live the dream.
Good evening, everyone. Good evening, sir. I would like you all to welcome at the PUC Mindspark series last day. We have chemistry session today, which will be taken by Ravi Shankar sir. The sir is already here with us. We'll start the session now. Yeah, Ravi sir, we are good to go. So we'll start the session.
Rikesh, can we start then?
Yes, sir, we can start, sir.
Yeah, right. So, good evening, students. Welcome back to our sessions on Mindspark series. Okay, and you know that we have done this Mindspark series for both CBSE as well as now we are doing it for Karnataka State Board, also PU Board also. Okay, already we have done maths and then we have done physics also, biology also. Today will be our last sessions. And today we'll be discussing about chemistry. We'll be discussing what are the important topics in this chemistry. what are the priority topics also? At the same time, before all discussing all those things, priority topic, weightage topics, important topics, okay, must study and questions and everything. Let us discuss about first what are the model paper what we are having this year, because this year you know that things have changed. Okay, ಮುಂಚೆ ತರ ಇಲ್ಲ ಈಗ ಅಲ್ವಾ, ಸ್ವಲ್ಪ ಚೇಂಜ್ ಮಾಡಿದ್ದಾರೆ. ಏನ್ ಮಾಡಿದ್ದಾರೆ, MCQ ನ ಆಡ್ ಮಾಡಿದ್ದಾರೆ. MCQ ಆಡ್ ಮಾಡಿದ್ರೆ ಏನಾಗಿದೆ ನಮ್ಗೆ, ಇನ್ಫ್ಯಾಕ್ಟ್ ಥಿಂಗ್ಸ್ ಹ್ಯಾವ್ ಬಿಕಮ್ ಮಚ್ ಈಸಿಯರ್. ಈಗ ಮುಂಚೆ ತರ ಈಗ ಪೇಪರ್ ಕಷ್ಟ ಇರೋದಿಲ್ಲ. ಯಾರು ಸ್ವಲ್ಪ ಓದಿರ್ತಾರೆ ಅವ್ರು ಈಸಿಲಿ ದೇ ಕ್ಯಾನ್ ಟೇಕ್ ಅಪ್ ದಿಸ್ ಪೇಪರ್. ಬಹಳ ಜನ ಅನ್ಕೊಂಡಿದ್ದಾರೆ MCQ ಇದ್ರೆ ಕಷ್ಟ ಆಗುತ್ತೆ ಅಂತ. ಇಲ್ಲ, MCQ ಇದ್ರೆ ಕಷ್ಟ ಆಗಲ್ಲ. ಯಾಕೆ ಸರ್ ಕಷ್ಟ ಆಗೋದಿಲ್ಲ? ಯಾಕೆ ಅಂದ್ರೆ ಈ ಪೇಪರ್ನ ಯಾವ ರೀತಿ ಮಾಡಿದ್ದಾರೆ ಅಂದ್ರೆ, ಮೋಸ್ಟ್ ಆಫ್ ದೀಸ್ MCQs, ಓಕೆ, ಐ ವಿಲ್ ಜಸ್ಟ್ ಟೇಕ್ ಎ ಪೆನ್. ಮೋಸ್ಟ್ ಆಫ್ ದಿ MCQ ಇದೆಯಲ್ವಾ, ಏನ್ ನಮ್ಗೆ 20 ಕ್ವಶನ್ಸ್ ಇರುತ್ತಲ್ವಾ, ಆ 20 ಕ್ವಶನ್ಸ್ನು ಖಂಡಿತವಾಗಿ ಅವ್ರು ಹೇಳಿದ್ದಾರೆ ಸಿಂಪಲ್ ಆಗಿರೋದೇ ಕೊಡ್ಬೇಕು ಅಂತ ಹೇಳಿದ್ದಾರೆ. ತುಂಬಾ ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ದೇ ವಿಲ್ ನಾಟ್ ಆಸ್ಕ್. ಸರ್ ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಕ್ವಶನ್ಸ್ಗಳು ಏನಾದ್ರು ಬರುತ್ತಾ, ಮಲ್ಟಿಪಲ್ ಕಾನ್ಸೆಪ್ಟ್ ಕ್ವಶನ್ಸ್ ಏನಾದ್ರು ಬರುತ್ತಾ ಅದರಲ್ಲಿ? ಸೊ ಅದರಲ್ಲಿ ಅಪ್ಲಿಕೇಶನ್ ಓರಿಯೆಂಟೆಡ್ ಕ್ವಶನ್ಸ್ ಏನಾದ್ರು ಬರುತ್ತಾ ಯಾವ್ದ್ರಲ್ಲಿ? ಆ ಮೊದಲ 20 ಕ್ವಶನ್ಸ್ ನಲ್ಲಿ ಖಂಡಿತ ಬರೋದಿಲ್ಲ. ರಿಮೆಂಬರ್ ದಿಸ್ ಪಾನ್. ಯಾಕೆಂದ್ರೆ ಬೋರ್ಡ್ನವರೇ ಅದಕ್ಕೆ ಕ್ಲಾರಿಫೈ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ. ದೇ ಹ್ಯಾವ್ ಟೋಲ್ಡ್ all these complicated questions will not come in this MCQ. Will not come, sir. Only simple questions will be asked in this MCQ. ಅದರಲ್ಲೂ ಅಡ್ವಾಂಟೇಜ್ ಏನು ಅಂದ್ರೆ, ಈ 20 MCQ ನಲ್ಲಿ ಇನ್ ದಿಸ್ ಓನ್ಲಿ 15 ಏನಿರುತ್ತೆ ಆಬ್ಜೆಕ್ಟಿವ್ ಟೈಪ್. ರಿಮೈನಿಂಗ್ 5 ಕ್ವಶನ್ಸ್ ಫಿಲ್ ಇನ್ ದಿ ಬ್ಲಾಂಕ್ಸ್ ಅಲ್ವಾ. ಆ ಫಿಲ್ ಇನ್ ದಿ ಬ್ಲಾಂಕ್ಸ್ ಗೆ ಆನ್ಸರ್ ಅವರೇ ಕೊಟ್ಬಿಟ್ಟಿರ್ತಾರೆ. ಈ fill in the blanks ಗೆ ಆನ್ಸರ್ ಇಸ್ ಗಿವನ್. ಓನ್ಲಿ ಯು ಹ್ಯಾವ್ ಟು ಚೂಸ್ ದಿ ರೈಟ್ ಒನ್ ಅಷ್ಟೇ. ಸೊ ಇಟ್ಸ್ ಕ್ವೈಟ್ ಮಚ್ ಈಸಿಯರ್ ದಿಸ್ ಇಯರ್. ಈಸ್ ಬಹಳ ಈಸಿ ಇರುತ್ತೆ. ಲೆಟ್ ಅಸ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಹೌ ದಿಸ್ ಕ್ವಶನ್ ಪೇಪರ್ ವಿಲ್ ಬಿ. ಅದ್ರ ಬಗ್ಗೆ ಒಂಚೂರು ಡಿಸ್ಕಸ್ ಮಾಡಿ ದೆನ್ ವಿಲ್ ಮೂವ್ ಆನ್ ಟು ದಿ ಆನ್ಸರ್ಸ್ ಆಫ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಮಾಡೆಲ್ ಪೇಪರ್. ಅದಾದ್ಮೇಲೆ ದೆನ್ ವಿಲ್ ಡಿಸ್ಕಸ್ ಅಬೌಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್, priority question, then must questions, all those things we'll discuss. First one, ಈ ನಮ್ಮ ಮಾಡೆಲ್ ಕ್ವಶನ್ ಪೇಪರ್ ನಲ್ಲಿ ಯು ನೋ ದಟ್ ಒನ್ there will be a 4 parts. Remember this one. ಸೊ ಪಾರ್ಟ್ A ಇರುತ್ತೆ, ಪಾರ್ಟ್ B ಇರುತ್ತೆ, ಪಾರ್ಟ್ C ಇರುತ್ತೆ, ಪಾರ್ಟ್ D ಇರುತ್ತೆ. ಅದರಲ್ಲಿ 5 ಕಂಪೋನೆಂಟ್ಸ್ ಇರುತ್ತೆ. 1, 2, 3, 4, 5. 5 ಕಂಪೋನೆಂಟ್ಸ್ ಇರುತ್ತೆ ಸರ್. ಸೊ ಇದರಲ್ಲಿ 5 ಕಂಪೋನೆಂಟ್ಸ್ ಇರುತ್ತೆ. ಇದು ಫಸ್ಟ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ನಾನು ಇವತ್ತೇನು MCQ ಕ್ವಶನ್ಸ್ ಅಂತ ಹೇಳಿದೆ, ಅದು 20 ಕ್ವಶನ್ಸ್ ಇಲ್ಲಿ ಪಾರ್ಟ್ A ನಲ್ಲಿ ಬರುತ್ತೆ. ಸರ್ ಪಾರ್ಟ್ B ನಲ್ಲಿ ಯಾವ್ದು ಬರುತ್ತೆ? ಪಾರ್ಟ್ B ನಲ್ಲಿ ನೀವು ಬರೀ 4 ಕ್ವಶನ್ಸ್ ಬರೀಬೇಕು. ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಇದೆ ಸರ್? ಸರ್ ಇದು 2 ಮಾರ್ಕ್ಸ್ಗೆ ಸರ್. ಸರ್ ಪಾರ್ಟ್ C ನಲ್ಲಿ ಅಲ್ಲೂ 4 ಕ್ವಶನ್ಸ್ ಬರೀಬೇಕು. ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಸಿಗೋದು? 3 ಮಾರ್ಕ್ಸ್ಗೆ. ಸರ್ ಪಾರ್ಟ್ D ನಲ್ಲಿ ಅಲ್ಲಿ ಸರ್ 2 ಕಂಪೋನೆಂಟ್ಸ್ ಇದೆ, 4 and 5. ಇವೆಲ್ಲದೂ ಅಷ್ಟೇ 5 ಮಾರ್ಕ್ಸ್ ಕ್ಯಾರಿ ಮಾಡುತ್ತೆ. ಈ ಪಾರ್ಟ್ 4 ಕಂಪೋನೆಂಟ್ ನಲ್ಲಿ ಇನ್ಆರ್ಗಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿಯಿಂದ ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿರ್ತಾನೆ, ಇಲ್ಲಿ ಆರ್ಗಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿಯಿಂದ ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿರ್ತಾನೆ, ಅಷ್ಟೇನೇನು ಇಲ್ಲ. ಫಸ್ಟ್ ಇದು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಎಷ್ಟು ಪಾರ್ಟ್ ಇದೆ? 4 ಪಾರ್ಟ್ ಇದೆ, 5 ಕಂಪೋನೆಂಟ್ ಇದೆ. ಆ ಪಾರ್ಟ್ D ನಲ್ಲಿ 2 ಕಂಪೋನೆಂಟ್ ಬಂದ್ಬಿಡುತ್ತೆ, 4 and 5. ಆಮೇಲೆ ನೋಡಿ ಎಷ್ಟು ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿದೆ ನಿಮ್ಗೆ. ಪಾರ್ಟ್ B ನಲ್ಲಿ 8 ಕ್ವಶನ್ಸ್ ಇರುತ್ತೆ. ಯು ಜಸ್ಟ್ ಹ್ಯಾವ್ ಟು ರೈಟ್ 4. ಪಾರ್ಟ್ C ನಲ್ಲಿ 8 ಕ್ವಶನ್ಸ್ ಇರುತ್ತೆ, ನೀವು 4 ಬರೀಬೇಕಷ್ಟೆ. ಅದೇ ತರ ಪಾರ್ಟ್ D ನಲ್ಲಿ ನೋಡಿ 5 ಕ್ವಶನ್ಸ್ ಇರುತ್ತೆ, ನೀವು ಬರೀ 3 ಬರೀಬೇಕಷ್ಟೆ. ಇದು ನಮ್ಮ ಕ್ವಶನ್ ಪೇಪರ್ ಆಯ್ತಲ್ವಾ. ಈಗ ನಿಮ್ಮ ಎಲ್ಲ ಸಿಲೆಬಸ್ ನ ತಗೊಂಡ್ರೆ ಎಷ್ಟು ಚಾಪ್ಟರ್ ಇದೆ? 16 ಚಾಪ್ಟರ್ ಇದೆ. ಈ 16 ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಗೊತ್ತಿರ್ಲಿ, ಲಾಸ್ಟ್ 2 ಚಾಪ್ಟರ್ ಇಂದ MCQ ಬರೋದಿಲ್ಲ ಸರ್. MCQ ಕ್ವಶನ್ಸ್ ಲಾಸ್ಟ್ 2 ಚಾಪ್ಟರ್ಸ್ ಇಂದ ಬರೋದಿಲ್ಲ. ಈ 14 ಚಾಪ್ಟರ್ ಇಂದ ಮಾತ್ರ MCQ ಕೇಳ್ತಾರೆ. ಅದನ್ನ ಹೇಳ್ತೀನಿ ನಮ್ಗೆ ಯಾವ ಚಾಪ್ಟರ್ ನಲ್ಲಿ ಎಷ್ಟನೇ ಕ್ವಶನ್ಗೆ ಎಷ್ಟನೇ ಚಾಪ್ಟರ್ ಇಂದ ಕ್ವಶನ್ ಬರುತ್ತೆ ದಟ್ ಐ ವಿಲ್ ಟೆಲ್ ಯು. ಅಂಡ್ ಈ ಮೊದಲನೇ 5 ಚಾಪ್ಟರ್ಸ್ ನ ಸಾಲಿಡ್ ಸ್ಟೇಟ್, ಸೊಲ್ಯೂಷನ್, ಎಲೆಕ್ಟ್ರೋಕೆಮಿಸ್ಟ್ರಿ, ಕೈನೆಟಿಕ್ಸ್, ಸರ್ಫೇಸ್ ಕೆಮಿಸ್ಟ್ರಿ ನಾವೇನ್ ಹೇಳ್ತೀವಿ ವಿ ಕಾಲ್ ಇಟ್ ಫಿಸಿಕಲ್ ಕೆಮಿಸ್ಟ್ರಿ. ಹೌದಾ? ಆ ಫಿಸಿಕಲ್ ಕೆಮಿಸ್ಟ್ರಿಗೆ ನೋಡಿ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಇದೆ. ಯು ಪ್ಲೀಸ್ ಆಡ್ ಇಟ್. ಸರ್ 39 ಮಾರ್ಕ್ಸ್ ಇದೆ. ಇದು ಬೇಡ, ಇದು ಅವರ್ಸ್ ಇದು ಬಿಡಿ. ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಇದೆ? 39 ಮಾರ್ಕ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ.
Excuse me, sir.
ಎಸ್.
So students are asking, sir, if you could speak in English.
Okay. I can speak, no problem. We will do
Yes,
it.
sir. Sir, also there is one more question. Sir, will the board question paper will follow blueprint of model paper?
Sorry, what I'm not getting you to that?
Sir, a student is asking, will the board question paper will follow blueprint of model paper?
Yes. They have to follow the blueprint only. ಅದು ಎಲ್ಲರಿಗೂ ಚೆನ್ನಾಗಿ ನೆನಪಿರ್ಲಿ. ಅವ್ರೇನಿಗೆ ಪ್ಯಾಟರ್ನ್ ಕೊಟ್ಟಿದ್ದಾರಲ್ಲ ಆ ಪ್ಯಾಟರ್ನ್ ಫಾಲೋ ಮಾಡಬೇಕು. ದೇ ಕೆನಾಟ್ ಗೋ ಅವೇ ಫ್ರಮ್ ಕ್ವಶನ್ ದಿಸ್ ಪ್ಯಾಟರ್ನ್. ಯಾರೇ ಕ್ವಶನ್ ಪೇಪರ್ ಸೆಟರ್ ಆದ್ರೂ ಅವರು ದೇ ಹ್ಯಾವ್ ಟು ಫಾಲೋ ದಿಸ್ ಪ್ಯಾಟರ್ನ್. ಈಗ ನಾನೇ ಕ್ವಶನ್ ಪೇಪರ್ ಸೆಟ್ ಮಾಡ್ತೀನಿ ಅನ್ಕೊಂಡ ಹೆಂಗ್ ಬೇಕು ನನಗೆ ಬುದ್ಧಿವಂತಿಕೆ ಇದೆ ಅಂದ್ಬಿಟ್ಟು ನಾನು ಹೆಂಗೆ ಕ್ವಶನ್ ಪೇಪರ್ ಸೆಟ್ ಮಾಡಕ್ ಬರೋದಿಲ್ಲ. ಅವ್ರು ಬೋರ್ಡ್ನವರು ಒಂದು ಗೈಡ್ಲೈನ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ಆ ಗೈಡ್ಲೈನ್ಸ್ ಪ್ರಕಾರ ನಾನು ಪ್ರಿಪೇರ್ ಮಾಡ್ಬೇಕು. ಮತ್ತೆ ಇಲ್ಲಿ ನನ್ನ ಬುದ್ಧಿವಂತಿಕೆ ಪ್ರದರ್ಶನ ಮಾಡಕ್ಕಿಲ್ಲ ಅವಕಾಶ ಇಲ್ಲ. ನಾನು ಮಕ್ಕಳನ್ನ ಗಮನದಲ್ಲಿ ಇಟ್ಕೊಂಡು ಅದಕ್ಕೊಂದು ಫ್ರೇಮ್ ವರ್ಕ್ ಇದೆ. ಇಷ್ಟೇ ಅಪ್ಲಿಕೇಶನ್ ಕ್ವಶನ್ ಬರಬೇಕು, ಇಷ್ಟೇ ಸಿಂಪಲ್ ಕ್ವಶನ್ಸ್ ಬರಬೇಕು, ಇಷ್ಟೇ ಮೆಮೊರಿ ಬೇಸ್ಡ್ ಕ್ವಶನ್ಸ್ ಬರಬೇಕು. ಬೋರ್ಡ್ ಯಾವಾಗ್ಲೂ ಅಷ್ಟೇ ಮಕ್ಕಳನ್ನ ಗಮನದಲ್ಲಿ ಇಟ್ಕೊಂಡು ಅದಕ್ಕೆಲ್ಲ ಒಂದು ರೂಲ್ಸ್ ಮಾಡಿರುತ್ತೆ ಕ್ವಶನ್ ಪೇಪರ್ ಸೆಟರ್ಗೆ. ಅದಕ್ಕೆ ಹೇಳಿದ್ ನಿಮ್ಗೆ ಬ್ಲೂ ಪ್ರಿಂಟ್ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರ್ಬೇಕು ನಿಮ್ಗೆ. ಆಮೇಲೆ ನೋಡಿ ಇಲ್ಲಿ ಇದ್ಯಾವ್ದು ಸರ್ ಇದು 6, 7, 8, 9 ಇಟ್ಸ್ ಇನ್ಆರ್ಗಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ. ಸೊ ಇನ್ ದಿಸ್ ಇನ್ಆರ್ಗಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಲುಕ್ ಅಟ್ ದಿ ಮಾರ್ಕ್ಸ್ ಅವೈಲಬಲ್. 31 marks is available. And the last one, what we call it as this particular group 3. So all this chapter, if you take 7 chapters, these are all organic chemistry chapters. And how many marks is there? Sir, 45 marks is there. So totally in your question paper, how many marks is there? Sir, 115 marks is there. Please remember, you are writing only 70 marks. So you have a lot of marks. You have many marks you are having. You can choose a question and you can write it. You have a lot of options. Question paper will be for 115 marks, but you are writing only for 70 marks. Have you understood? Yes or no? Please put it in chat box, all of you. Yeah, Gauri, I will tell you from where it will come. But is it right now? Have you understood? Please put it in a chat box if you understood. This is very, very important. Very good, very good. Aishwarya, Sadaf, very good. Umran, good. Tarun, fantastic. Sabir, Niranjan, yes. Niranjan, yes. Niranjan, TS, Vishal, Ujwal, Para, very good. Okay. Good. So this part you have to be very clear. Take a screenshot if you want. ಅಥವಾ ಈ ಸೆಷನ್ಸ್ ಆದ್ಮೇಲೆ ನನಗೆ ಜ್ಞಾಪಿಸಿ ಬೇಕಾದ್ರೆ ನಿಮ್ಗೆ ಅದನ್ನ PDF ಕಳಿಸ್ಕೊಡ್ತೀನಿ ನಿಮ್ಗೆ ಅದನ್ನ. Then what we have to do? ಈಗ ಸ್ವಲ್ಪ ಈ ಫಿಸಿಕಲ್ ಕೆಮಿಸ್ಟ್ರಿ ಬಗ್ಗೆ ಸರಿ ಯಾವ ಕಾಂಪೊನೆಂಟ್ ನಲ್ಲಿ ಎಷ್ಟೆಷ್ಟು ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ. And they have to follow this blueprint only. Remember this one. Already told you how many marks is there for physical chemistry. 39 marks is there. In that solid state now chapter ಇಂದ ನಮ್ಗೆ ಆ MCQ ನಲ್ಲಿ ಒಂದು ಕ್ವಶನ್ ಬಂದೇ ಬರುತ್ತೆ ಸರ್. This is one question is there. ಮತ್ತೆ ಇನ್ನೊಂದು ಕ್ವಶನ್ ಎಲ್ಲಿ ಬರುತ್ತೆ ಸರ್? ಪಾರ್ಟ್ ಬಿ 2 marks questions ಅಲ್ಲಿ ಬರುತ್ತೆ. Then where we are having sir, then in part D ನಿಮ್ಗೆ ಹೇಳಿದೆ 5 marks questions ಬರುತ್ತೆ. 5 marks question ಬರುತ್ತೆ. And I will tell you, most of these questions in solid states are very simple. Sir, MCQ will be very challenging, no, sir. Very MCQ na twist mark. They will give you a very complicated. No, I told you already. Very simple question will appear in MCQ. Remember this word. Remember my word, what I'm telling you. Very simple question. You can score it. Definitely you can score it. Then, sir, 2 marks question. Very simple question they will ask you. What is meant by ionic solid? Give example. Molecular solid? Give example. Covalent solid? Give example. Frankel defect, Schottky defect, difference between Frankel and Schottky. Something very simple one they give. And here also part D. And already you know that one. In part D, in a solid, there's a one compulsory question is there. What is that? Sir, packing efficiency. Sir, packing efficiency is a compulsory question. They will definitely give 3 marks. And you told 5 marks, no, sir. Yes, 5 marks always appears as a, always remember, in our chemistry, we don't give any question for 5 marks, one question. We never give one question 5 marks. Please remember, it is not. It is always 3 plus 2. Or how we give it? We give it as 3 plus 1 plus 1. Or we can also give it as 2 plus 2 plus 1. So they divide it like this. One question carrying 5 marks, they never give it. Remember this one. So packing efficiency 3 marks. So then what is another questions? They may ask you about write a note on Frankel defect. 2 points you have to write. 2 marks. Please remember, concentrate on classification of solids. Don't forget it. Okay, please. They may ask simple question like difference between crystal and amorphous, Frankel and defect. And then they may ask you N-type and P-type. They may ask you what is meant by paramagnetic component, what is meant by ferromagnetic substances. Very simple question they will ask you for 2 marks. Then coming to solution. And solution, look at the solution topic. You are having 3 questions in MCQ. But in this MCQ, sir, the second part is filling the blanks. You are having 1 question, and in MCQ, you are having 2 questions. Totally 3 questions are there in part A. Sir, part B null, no question. Part C null, no question. Part D null, again, there is a 1 question. And 5 marks. Already I told you, 1 question will not carry 5 marks. They usually divide it into 3 plus 2. Sir, what may be the question in solution? Mainly numerical, yeah. Mainly numerical. Usually, yaad barutte, sir, in numericals. Mainly determination of molecular weight. Elli, sir, in colligative property. Remember this one. Please study this 4 colligative property. You know that one. Sir, relative lowering of vapor pressure. Then elevation in boiling point, depression in freezing point, osmotic pressure. In these 4, they may ask you to calculate molecular weight of the solute. That you have to be ready. Next, coming to electrochemistry. In electrochemistry, you can see 1 question in MCQ, 1 marks, and 1 question in 2 marks category, and again 1 question in 5 marks category. Again, you'll be having a numerical here. Numericals. What are the numericals we have to study here? Mainly numerical is a Nernst equation. Then, sir, then Faraday's law. Usually it is in Faraday's first law. But study both first law and second law. You should be remembering it. Then, after that, other than that, sir, conductivity, either molar conductivity or equivalent conductivity. Then Collas law. Please remember it. So thus one questions will be for 3 marks, another questions will be for 2 marks. So 2 marks what they may give? They may give you, write the cathodic reaction in a lead storage cell. Just you have to write the cathodic reaction. Something like this, simple one. What is a strong electrolyte? Give example. A simple one they will ask you. Give example. Something like this. Next, we'll go to electrochemistry. One question in 1 mark and one question in the electrochemistry we have done now. Then chemical kinetics. One question in part A, that is in MCQ. One question in fill in the blanks. Very simple question they will ask you, like what is the unit of a first order reaction? Dash. Unit of a zero order reaction? Dash. Remember, they will ask you only these two, zero order and first order, nothing else. Please concentrate on that. Anything, very simple one they will ask you. Then one question in 2 marks, then one question in 5 marks. You know that in 5 marks question, again it is 3 plus 2. Usually 3 plus is, already compulsory question. Derive rate constant expression for, sir, zero order or it is for first order. Next we'll go. So surface chemistry. This chapter, though, compared to all the chapter, very easy. Memory based this is. What are the topics? There are only 3 topics. Sir, adsorption. Then we have to discuss about catalyst. Then we have to discuss about colloids. Very simple chapter. Don't leave it. In adsorption, what you have to study? Only you have to study physical adsorption and chemical adsorption. Over. One more topic is, sir, adsorption isotherm you have to study. Only friendly adsorption isotherm you have to study. Over. So catalyst, positive catalyst, negative catalyst, promoter, inhibitor, homogeneous, heterogeneous, and how catalyst will decrease A. It will decrease the energy of activation and the characteristics of catalyst. In colloids, mainly classification. Please don't forget your ready study classification. So classification based on affinity, classification based on physical state, like emulsion, gel, sol. Classification based on types of particle, means associated, multimolecular, and macromolecular. This classification. Then properties of colloids, purification of colloids, preparation of colloids, then coagulation. Sir, Ardiscu's role. Very important, Ardiscu's role. Little bit of gold number also. Not required. Okay. And how many questions are there in this one, sir? Remember this one. One question from sir MCQ, that is in part A, MCQ. And one question in part D. So totally 5 plus 1, 6 marks will be there. So this is about physical chemistry. So what about inorganic chemistry? If you look at inorganic chemistry, it's easy to study. So what is this? First topic, metallurgy. Memory based again. How many questions? 1 questions in part A and 1 question in part C. No question in part B and D. That is only 3 marks questions will be asked here. So today 3 plus 1, 4 marks, sir. And in a P block element, and this P block element, no, what you do, don't study it together. You divide it into subgroups, subtopics. First, you divide it into, sir, group for 15, 16. Don't study everything together, 18. And 18th noble gas, only 2 pages will be there, just. Don't leave it. Okay, 2 MCQ will come only from this group 18. Group 18. 2 MCQ. What is the MCQ? Look at here. In a P block elements, there are 2 MCQ are there. 2 MCQs. I will take another ink. It becomes easy. Sir, there are two MCQ are there. Two MCQ directly, sir, come from noble gas. Noble gas. Don't miss it. Then, in a 3 marks, you're having 3 questions. Don't miss it. Compulsory question. You know that one. Manufacture of ammonia. Don't miss it. Condition for manufacture of nitric acid. Manufacture of sulfuric acid. Don't miss it. Then, so these are the 3 questions here. 3 3s are 9. 9 plus 1, 10, sir. 10 plus 1, 11 marks is there. So remember, in a P block, we don't have any questions in B and D. Then coming to D and F block elements. So D and F block element. Very easy chapter. F block though, just a very important topic you have to discuss. Lanthanide contraction, actinide contraction. Little bit difference between actinides and lanthanides. In a D block, most of the things what we study in coordination component D and F block, no, both gets repeated. So you can study these 2 chapters together. 2 chapters together. Very important is don't forget 3D series. Don't forget 3D series. Very important. I want you people to know about all the elements in 3D series. Don't miss it. Don't miss it. Sir, how many marks is there? 9 marks is there for this D and F block. Look at it. Both the chapters are same. 9 plus 7. Sir, 16 marks is there. You can take it as a same chapter. Both the chapter. And how many questions? MCQ 1 question, sir. And in part C, look at here. 2 questions are there. And most of these questions are you can easily analyze and predict. Sir, in a D block, you know that one. 1 question to compulsory, KMNO4, preparation of KMNO4, or preparation of potassium dichromate is a compulsory question, you know that one. Don't miss it. In a coordination compound, you know that compulsory question is valence band theory. We have just discussed 4 complex in our syllabus. No, be thorough about this 4 complex. What are the things you have to tell? You have to tell about hybridization. Sir, you have to tell about geometry. And you have to tell about magnetic nature in this 4 complex. You can easily predict. That's why I told you, this question paper will not be difficult. Then, coming to last component, what is this, sir? Organic chemistry. Organic chemistry. What are the things to study in organic chemistry, sir? Alloalkane, alloranes. How many marks are there? 7 marks are there. Very important is don't forget name reaction. Don't forget name reaction in alloalkane and alloranes. Starting from preparation. What are the reactions, sir? First one is Schwarz reaction. Finkelstein. They're repeating every time. So Finkelstein reaction. Then Darzon's reaction. All these things you study in preparation. Then if you go to properties, sir, we study about Wood's reaction. Then we study about, sir, Wood's fatigue reaction. We study about fatigue reaction. We study about Friedel-Crafts alkylation. So we study about Friedel-Crafts alkylation. Don't forget this name reaction. So Friedel-Crafts alkylation and acylation. Acylation. Then last, don't forget Williamson ether synthesis. So Williamson ether synthesis. These are all name reaction. And mechanism is, you know that one. Nucleophilic substitution reaction. There you study about 2 mechanisms. SN1 and SN2. Don't forget. This will be for 3 marks. Where you get it, sir? You get it in part D. Part D will be in 5 marks. 5 marks means they give it as I told you, 3 plus 2. In that 3 plus 2, 1 question will be on mechanism, definitely. Then another 2 marks, sir. Say if this is 3 marks, what is the other 2 marks? Any simple question like Williamson ether synthesis, Wood's reaction, fatigue reaction. What are the reaction you study? You study only 3 reaction. Nucleophilic substitution reaction. Nucleophilic substitution reaction. Then reaction with metal. Then beta elimination. These are the 3 reactions you study. So how many marks you get? 7 marks, sir. 5 marks in part D. And there are 2 questions in part A, sir. Part A. Very simple question they will ask you. Coming to alcohol phenol ethers. Again, look at there. Part D. In all this organic chemistry, observe here. If you observe here, in part D, compulsory, we are having one question. If you observe the inorganic chemistry, look at it. In inorganic chemistry, in part C, compulsory, you're having one questions. You're having three questions. Look at it. Metallurgy 1 question, P block 3 question, D block 2 question, coordination 2 compound. This is all part C, 3 marks question. Whereas in inorganic organic chemistry, look at this one. Part C, we don't have any question, but part D, we are having 1 question in every chapter, except chemistry level. Because here you have only 5 marks. In that 5 marks, 2 questions will appear for 2 marks in part B and 1 question here. Otherwise, you have a 5 marks question in every topic. And you easily you can predict what kind of reaction, what kind of questions they ask. Coming to alcohol, sir. Then alcohol, sir, what kind of questions may appear for 8 marks? So you told 5 marks will be there. In that 5 marks, I told you 3 plus 2. 3 plus 2. What are the questions they may ask here, sir? In 3 marks, mainly mechanism. You have hydration of, sir, hydration of alkenes to alcohol. Alkenes to alcohol. Don't forget. In the same way, you also have a mechanism for dehydration. Sir, dehydration of alcohol to alkene. Both the mechanism don't leave it. Then, sir, name reaction. All the name reaction, whether I tell you or not, all name reactions are important. What are the name reactions in this alcohol, phenol, and ethers? Again, look at here. Williamson ether synthesis. Then, sir, what are the other reaction you're having? Preparation of phenol from cumin. Very frequently they ask cumin to phenol. Then name reactions, sir. Reimer-Tiemann reaction. Reimer-Tiemann reaction. Then Cope's reaction. Only few name reaction. Please don't forget it. There is a more probability that they will all come. Because in a part B, you are having a 1 question there. 2 marks. And part D also, when you say 3 plus 2, he has to give it as 3 plus 2, or he has to give it as, I told you, 3 plus 1 plus 1, or he may give it as 2 plus 2 plus 1. He has to take up those questions. Sir, tell me what are the important aspect in alcohol? In alcohol, don't forget preparations. Any topic, no. Please concentrate on preparations. Don't forget preparations. Then, important preparation of all alcohol. How many methods are there? Only 3 methods are there. Sir, phenol, how many methods are there? 4 methods are there. Very simple reactions. Sir, ether, only 2 preparations are there. One is from Williamson ether synthesis, another is from alcohol. Then, so properties, what are the important properties? In alcohol, don't forget reaction of alcohol with Lucas reagent. Lucas reagent. Very frequently asked question. Then Acidic nature of alcohol. Nature of alcohol. Then a little bit about methanol and ethanol. Methanol and ethanol. So when I take phenol, what are the important properties? Very important is acidic nature. Don't forget. Acidic nature of phenol, that you have to discuss. Then ESR reaction of phenol. ESR reactions of phenol. So when I come to ether, what are the important topics? Very simple. Reaction with HI, don't forget. With HI. What are the reaction? How HI reacts with symmetrical ether? How it reacts with unsymmetrical ether? How it reacts with aromatic ether? One more is there. How it reacts with ether containing tertiary group. How it reacts with ether containing tertiary alkyl group. Because this is, that one, SN1 reaction. All other are SN2, sir. Then one more reaction is that ESR reaction. In all this ESR reaction, you get ortho and para groups. Whether it is a phenol, whether it is ether, you're going to get ortho and para. I will discuss it later. Then, sir, aldehyd ketone carboxylic acid. How many marks? 8 marks. Again, 5 marks and 2 marks in part B and 1 question in MCQ. Very simple one they will ask you. Again, I told you, don't forget name reactions. What are the name reactions here? In preparation, Rosenmeier. Stephen's reduction. Sir, Itard reaction. Gutterman reaction. Gutterman-Koch reaction. Then, very, very important. When I say reduction, you remember 4 kind of reduction. Already I told you 2 reduction. Rosenmeier reduction, Stephen's reduction. Then, sir, you're also having in properties you will come across where you convert aldehyd into hydrocarbons. Which are those? Sir, Wolff-Kishner reduction. Very important. All name reaction, whether I tell you or not, you should remember it. You should remember it. Then, how aldehys and ketones react with? Which one undergoes nucleophilic addition reaction? There are 2 kinds of reaction. Nucleophilic addition reaction and nucleophilic addition elimination. Very simple reaction. Don't forget. Here 7 reactions, here 4 reactions. Then other than that, sir, what happens when aldehyd undergo oxidation? Please study it. Only 4 reactions. What happens when aldehyd undergo oxidation? What happens when ketone undergo oxidation? What happens when they react with Tollin's reagent? What happens when they react with Falling solution? That's it. And in reduction, again 4 reaction. What happens when aldehyd undergo reduction? What happens when ketone undergo reduction? Then I told you now. What happens when they undergo reaction with zinc amalgam? What happens when they undergo reaction with hydrazine? This is called as Clemenson's reduction. This is called as Wolff, already I told you. Clemenson's reduction. Then Cannizzoro's reaction. All this divide the topics into subtopics. And you should know what you have to study. That's it, nothing else. Easily you can get 8 marks in this. And in carboxylic acid, sir, important is acidic nature, remember. And one important name reaction, Yell-Wollard-Zelinsky reaction. Enough. Coming to amines. Amine is a very small topic, but still you are having 6 marks. 1 question in a part A and 1 question in a part D. 5 plus 1, 6 marks, sir. In amine, sir, what are the important topic? Whether somebody tells you or not, please remember basic nature of amines. What is the basic nature in gaseous space? What is the basic nature in aqueous space? Gaseous space, the tertiary is more basic than secondary and primary, like this. Aqueous, secondary is more than primary and tertiary, more than ammonia. Then role of electron donating group. Oh, electron donating group increases basic nature, like this. You should study about basic nature a little bit. And comparison. What is the comparison? Aliphatic amine. Aliphatic amine with aromatic amine. Aliphatic is always more basic. Then compare methylamine with ammonia. Then compare aralkylamine with aromatic amine. Usually aromatic means aniline. This is compulsory basic nature. One question will be there. Other than that, name reaction. Don't forget. Which is the name reaction? Sir, Hoffman bromide reaction. Don't forget. You will get question there. Sir, carbolamine reaction. You will get question there. Sir, Innsbruck reagent. Whether somebody tells you or not, please make a note of all these things. Make a notes. Note is what we have to study during PU board. Don't keep books and everything. Your notes, what you have to keep. I'll come to that later. So this is in amines. What about in amines? There's one more topic. What is the topic? Sir, diazonium salt. In amines, yeah, one more topic, diazonium salt. Many students, they leave it. Don't leave it. You will get compulsory question here. Very simple. Only one preparation. How to get diazonium salt by using aniline. Aniline to diazonium salt. Only one preparation. Diazotization. Please study it. Most of the time, the question is there on that one. So after this preparation, in properties, what are the properties? Very important. Sandmeyer's reaction. Then, sir, Skymon reaction. Then, Gutterman reaction. Gutterman reaction. Coupling reaction. Coupling reaction, there are only two. Don't forget it. With aniline and with phenol. Don't forget it. Usually they will ask this question. I'm telling important. You have to study everything, but what I'm telling is the important one. Then coming to, sir, biomolecules. In biomolecules, again, you are having 6 marks. Very important, simple chapter. What are you having? You are having carbohydrates. Sir, you are having proteins. All these things already you have studied in biology. So it's a very easy. Nucleic acids and vitamins. Make a chart of vitamin. That's it, over. Vitamin A, D, E, K, fat soluble and water soluble. Vitamin B and C. B and C. In a nucleic acid, you know about nucleotides. You know about nucleosides. And nucleic acids are made up of nucleotide. There are 3 components: phosphoric acid, sugar, and nitrogen base. Please study about it. Chargafra, complementary base pairing. You all know about it. Proteins, concentrate on amino acid. Proteins are made up of amino acid. Concentrate on amino acid. And you know that there are 20 essential or 20 standard amino acid which makes protein. In that, please study the simple amino acid first. Very important. You should know the structure of it. You should know the structure and classification. Then, please know the structure of deuterium and how it is formed. Then, classification based on nutrition, essential and non-essential. Very frequently asked questions. Structure, don't leave it. It gives you a lot of idea about this particular chapter. Then amino acid makes protein. So in protein, what you have to study? Mainly protein classification. and structural organization. That is primary structure, secondary structure, tertiary, and quaternary. Very important. Then denaturation. This is in proteins. So coming to carbohydrates. So what are the things I have to study in carbohydrates? First thing is that structure of glucose. Don't forget. Alpha structure, beta structure, open chain structure. Don't forget. The structure of sucrose. Only 3 disaccharides: sucrose, maltose, lactose. And in polysaccharide, only cellulose, starch, glycogen. Just little bit of working 2 to 3 times, you'll get the structure of it. Very easy. Then you should know about classification of carbohydrate. In that classification, there are 2 types based on sweetness. So based on sweetness, there are mainly 2 types: sugar and non-sugar. Sugar are again classified into reducing and non-reducing. And this is very important. Frequently asked question on reducing and non-reducing. Then one more classification is there based on number of sugar in it. You can classify it into monosaccharide, then oligo. Please go through it. Very important. Then polysaccharide. Frequently asked for. So these are the things what you have to study in this particular chapter, biomolecules. Let's go to polymers. Very simple chapter. This last 2 are very simple chapter. Polymers and chemistry in everyday life. In chemistry everyday life, just make a notes. Like what are the things are they say? They will ask you what is meant by antipyretic drugs. What is antipyretic? You may write a simple word. They lower body temperature. Any chemical which lower body temperature is called as antipyretic. And remember, example given in textbooks. Enough. They're analgesic. What is analgesic? Sir, they reduce pain. They reduce pain. Enough. This much is enough. Reduce pain. And write example. So what is antacid? Like this, you make a one small note. They reduce acidity. Enough, you can write it in your own words. Write some example. Sir, what is an anti-fertility drug? Prevents pregnancy. Prevent pregnancy. Keyword you write, you'll come to know. You write example. Over. Like this, you make a chart. The chapter is over. Chapter is over. Then little bit of antibiotics. In antibiotics, there are 4 types. Please remember that one. Study all those things. Bactericidal, bacteriostatic, narrow spectrum, broad spectrum. Then study about little bit about disinfectant. Then little bit about antiseptic. At last, about soaps and detergent. This chapter is over. In detergent, there are 3 types: anionic, cationic, neutral, or non-anionic. Very easy to score. How many marks are there? Sir, 5 marks are there. Polymers, just you have to study my students' classification. Don't forget it. And make a chart where don't write all cock and bull stories. Very simple. Just write structure of a polymer. And what is the monomer? That's enough. You get an idea. Say, for example, somebody asks you polythene. What is polythene? You should know the structure of polythene. Sir, CH2. It's made up of ethene, where double bond becomes single bond. On both the side, put dash. And this is the structure of ethene and polythene. What is the monomer? Monomer is ethene, sir. Over. Like this, you make a chart for all the polymers. You'll get a fantastic idea. What are the polymers you have to study? You have to study two polymers, addition polymers and condensation polymers. What is the condensation polymer you have to study? Nylon. In it, nylon how many? Nylon 66, nylon 66, nylon 26. That's it. Don't study anything else. Then terylene. You study about terylene. Then you study about this one. Bakelite. Urea formaldehyde. Melamine formaldehyde. In addition polymers, you study about polythene. You make a list like this and make a chart, polythene. Then we study about mainly Serpan, polyacrylonitrile. Then we study about Teflon, sir. Then we study about rubber, natural rubber. Then we study about artificial rubber. Sir, Bunayan. Then neoprene. Like this, you make a chart. So only these polymers you should know in polymers. What polymers you should know? Condensation polymers and addition polymers. My dear friend, make a chart like this. On one side, read the structure, other side, read the monomer. You get a very good idea about this chapter. Easy to score. I will tell you about all this chapter at last. First, let us complete one model paper. Complete one model paper. And how to approach it? I told you. Very simple. You are having 16 chapters. In this 16 chapter, my dear student, plus first you classify. I will not classify. You classify what is easy for you, what is difficult for you. You classify what is easy and what is difficult. And then what you do, you just once revise easy, whether you have made a notes for it. Please check it. I have done a notes for it. One small notes you have to make. Because that's what required in examination, not the textbook. Not the textbook, I repeat. I have done your notes on the chapter, what you say, you say, I know it, sir. Whatever you know, you make a notes on it. Whether it is ready, make a short notes. Not a long notes now, make a short notes. Then one thing is completed, then see what are the difficult chapters. And what do you have to do? That difficult chapter, divide it into small units. Don't approach together. Divide into small units. It becomes very easy. Say, you think electrochemistry, there are too many numericals. Don't do like that. What you can do, electrochemistry, divide it into subtopics. So how to divide into subtopics? Say, for example, electrochemistry. First, study a little bit about Faraday's law. What is Faraday's law? There are only two laws. First and second law. Study it and then do problems on that one. Over. This part is over, sir. Then take Nernst equation and make a small chart of all these important formula, Nernst equation, sir, and do problem on that. Over. You divide it like this. Very, very important. Next, after this is over, electrode potential. What you have to study there? Electrochemical series. Make a notes of that electrochemical series. By using electrochemical series, you know that easily you can calculate E naught, which is very helpful in our Nernst equation. What is E naught of a cell? You write E naught of a cathode minus E naught of anode. And electrochemical series makes our job easier. There is an application of electrochemical series. Please study it and electropotential. Like this, divide your topic, whichever you think difficult, into subtopic, subtopic, and approach one topic at a time. And whatever you do, this is important. Whatever you have gone through, don't allow it to go waste. You have to revise it. You have to revise. What is revise? You have gone through, you have just studied it. Then what you do? Write it. Then what you have to do? Make a notes, make a short notes. All this comes here. Make a short notes. Sir, I've gone through it. Make a flow chart. In your own way, don't worry. Sit at one place and make a flow chart. Sir, I've gone through it. Make one map. Sir, I've gone through it. Write important keywords. Important keywords. You write it down. All these will help in revising it. Revising it. When you read, don't write, don't just read. You have to put all these efforts like this. Write, make a short notes, make a map, make a flow chart, write the keywords in every topic. Write the keywords. Say, for example, you have studied alloalkane and alloanes. So how to make one small short notes on that? I'll just give you. Alloalkane you have studied. What are these things you have studied? Preparation. How you prepared alloalkanes? So from halogenation of alkanes. Halogenation of alkane. Just write the topic. You'll come to know. Second. Then how we prepared? Sir, I prepared by using what? Halogen exchange method. That is Schwartz reaction. Sir, and Finkelstein reaction. Finkelstein reactions. So all these important points you keep on writing. So how many preparations are there? Sir, 4 preparations are there. Write it down. Then come to property. How many properties are there? Write down. So there are only 3 properties. Nucleophilic substitution reaction. Beta elimination. So reaction with metals. Over. Then again, subtopic. So reaction with metals. Sir, I have to study Wood's reaction. I have to study Wood's fatigue reaction. So I have to study Prudhomme-Kraft reaction. Like this. Again, subtopics. So it becomes easy. Then once you revised it, you have gone through it, you have revised it, but this part is what very important. Many people miss it here. They think they have studied. No. Take one white sheet and see whether you can repeat those points on a white sheet. That is called as recall. Sit at one place and simply just keep on remembering the points what you have gone through. Say you have studied around 5 points, but you will miss the third one. Don't worry. Everybody forgets. Just take the book and again go through it. This part is very, very important to recall. My dear student, you do this one, it becomes very easy. And remember, many people know they're telling, sir, this is the instruction given by board. I have not written this one. This is the instruction given by board. What they've told? No application type question should be there in the part A. Even the board only says no application based questions in part A. All question means all 20 questions simply should be knowledge based or moderate. What is moderate? Kasta irbardu. It is by board. I am not telling. Then look at it. In even remaining part, B, C, D, I have not told. Only 20% should be skill based. Means 20% is bit difficult, we can say. Only 20%. Remaining 80% is simple. 80% is simple. And in part A, all the questions should be only from 1 to 14. That is, no question from polymer. Remember, in part A, no question from polymer and chemistry nevertheless. Very important. And questions should be taken according to blueprint. We cannot take questions whatever we want. We have to go through according to blueprint. And remember, in part A, again, means MCQ. The fill in the blanks should be from chapter 1, 4, 7, 10, and 15. And in the chapter 7, that is in a P block, the question 8 and 18 should be from noble gas only. That means 18 group only. Means The MCQ in P block will come only from noble gas. So it becomes very easy to score it. So even though question paper is there for 150 marks, you have to write only for 70. You have a lot of choice. You have a lot of choice. They give you log table, they give you simple calculator. You have to take simple calculator, but not scientific. Okay. And in your purse and everything, don't carry metallic elements, all those things. Unnecessary things should not be there. They will send you back. They will take it. Simply, they become a complication. Just keep pen, pencil, rubber, and the simple calculator. We'll go to first question in MCQ. So due to Frenkel defect, the density of the ionic solid, what will happen? Is it increases or decreases or changes to small extent? So he says Frenkel defect. What is happening in Frenkel defect? Both cation and anion are not missing. So the cation and anion, they are not missing. They are present in the solid only. Only what they have done, they went into interstitial space. Means they have not left the solid. In the solid only, they went into interstitial space. So what will happen? What will be the answer then? So it does not change. So density will not change. What is density? So number of particle per unit area. Particle per unit area. So these are the, say, let us take the place where the solids are present, anion and cation are present. And these anion and cation are not missing. What they've done, they went into interstitial space. So the density does not change. Whereas in Schottky defect, sir. Whereas in Schottky defect. And always remember, in part A, the question 1 is from solids. Whereas in Schottky defect, what is happening? Sir, both anion and cations are missing. So they're missing, sir. Due to this, there is a vacancy. So density decreases. Density decreases. But whereas in Frenkel defect, sir, what is happening? They are leaving that place. Yes, that is true. But where they're going? So they're going into interstitial side. They're within the solid. They're within the solid. So there is no change in density. There's no change in density. No change in density. Only in Schottky defect, density decreases. So answer is, sir, it does not change. Next one. In which mode of expression the concentration of solution remains independent of temperature? And always, second question will be from solution. Remember this. In which mode of expression the concentration of solution remains independent of temperature? Is it volume percentage? Is it molarity? Is it molality? Is formality? Percentage means you know that one. The given volume divided by total volume into 100. That is volume percentage. So what is molarity? Molarity is all about what? 1 gram molecular weight of a substance in 1000 ml. That we call it as what? Molarity by the symbol m, sir. What is molarity? Molarity is also same thing. Sir, 1 gram molecular weight. 1 gram molecular weight of a substance. In, we'll not say 1,000 ml, we say 1,000 gram, or we simply say 1 kg. This is 1 liter. 1 liter. But he's not asking for definition. What he's asking? In which mode of expression the concentration of a solution remains independent of temperature? Independent of temperature. Sir, in both the case A and B, what will happen? When temperature increases, the volume will increase. When the volume increases, it affects both molarity and volume percentage. It cannot be. So this is also not possibility, sir. So the only answer is it has to be molality. It has to be molality. So molality gets affected by temperature. Yes, sir. Look at here. Sir, dependence. Look at this point. Molarity, yes, depends on the volume of the solution, depends on the atmospheric pressure, depends on temperature of a solution. But here, no, only depends on kilograms, mass. But both are same. Both is all about number of moles. Both about number of moles. This is in liter, this is in kg. That's it. And this is not affected by temperature. No, sir. But this is affected by temperature. So answer is, so it has to be molality. Next one. Third question will go. Again, third question is also from solution. Which of the following is not a collidative property? We already know that. I just now told you in collidative property, what is very, very important is determination of molecular weight of a solute. So what may be the answer? So definitely optical activity is not a collidative property. Why? What is collidative property? The property depends on number of particle. Depends on number of particles. What are the 4 collidative property? Sir, osmotic pressure is a collidative property. Elevation boiling point is a collidative property. Depression freezing point is a collidative property. One more is left. What is that? A relative lowering of vapor pressure. So relative lowering of vapor pressure. So that is also collidative. These are the 4 collidative property. 1, 2, 3, 4. And I told you, in all this collidative property, I told you what? Determination of molecular weight of solute is very important. Optical activity does not depend on the number of particles, so it is not a collidative property. And fourth question is always from electrochemistry. Remember this one. During electrolysis of molten sodium chloride, the reaction occurs at anode is, means we have to take sodium chloride and that one will dissociate, means it gets electrolyzed, means lysis means breaking by using electric current. When you pass electric current, it decomposes to give what? Na plus and Cl. That's what he's asking. What will happen at anode? Always remember, Na plus is a cation and Cl minus is an anion. And always in chemistry, cation goes towards cathode and anion goes towards anode. Goes towards anode. So that's what he's asking. What is happens at anode? So who is going at anode? Cl. What will happen there? The Cl minus will lose electron, and it becomes Cl plus E minus. And losing the electron is called as what? Oxidation. Losing electron is called as oxidation. So that is called as oxidation. So what may be the option? So chloride are oxidized. Yeah, anything is that you can please ask me that. So answer is, sir, A option. Let us check it out. Is it A? Yes, sir. Answer is A. Next one. Unit of a rate constant for a zero order reaction is. Unit of rate constant for a zero order reaction is. And already told you, in our syllabus, we have to concentrate more on zero order and first order. More. And also you should remember order of reaction. First, you definition. You should know the definition of order of reaction. What is order of reaction? Sum of the powers of concentration term in a rate equation of a reaction is known as order of a reaction. Say, for example, A give raised to B ಅನ್ಕೋಣ. ಆಗ ಅದಕ್ಕೆ ಏನು ಬರೀಬೇಕು? We have to write a rate equation. What is the rate equation? Which gives a relation between rate of reaction and the concentration of reactant. Which is the reactant here? A. Or we can write rate is equal to K into A to the power A. And by experiment, if you come to know that if it depends on A, we write it as 1. Means first order reaction. By experiment, if we come to know that it does not depend on A, we write it as 0. Means zero order reaction. And we should know what is the unit. What is the unit of this particular rate of a reaction, sir? Then you should know what is the K expression for zero order. You know that we have derived the rate constant expression for zero order reaction, is it not? What is that? Sir, initial concentration of A naught means reactant is equal to concentration of A divided by T. What is this? This is nothing but concentration term. The square bracket indicates what? Concentration. They indicate concentration. Concentration means what? Mole per dm cube. Sir, mole per dm cube. What is dm cube? Liter. It's liter. So the unit becomes, sir, mole per liter per second. Time means second. So we can write it as mole per liter per second. Per liter means L minus 1. L minus 1. So is that possibility? Let us check it out. Yes, sir. Answer is C. Mole per liter per second, sir. Per second. So these are the units of zero order and first order. Zero order, I told you, Kt is equal to R naught by R. No. So we can write K is equal to what? Concentration by time. Concentration is mole per liter divided by second. Like that for a first order reaction, remember this one, first order is just per second, that's it. Why, sir? The concentration gets cancelled. It's just a 1 by T, nothing but per second. So the answer is, sir, option C. Next one. In the process of adsorption, what may be the answer? What is adsorption? Accumulation of a gas particles on the surface of a solid. When this is a gas molecule gets adsorbed on the surface of a solid, we call it as adsorption, a surface phenomenon. Yeah, Madhu Acharya, tell me. So this is adsorption. During this adsorption, what will happen? We say, sir, randomness decreases. That is entropy. Entropy means yes. Sir, delta S decreases, we call it as. And during this, small amount of heat is liberated. We call it as enthalpy of adsorption. Enthalpy means what? Delta H. So heat is liberated means that becomes negative. Delta S decreases means that is also becomes negative. Negative. And we know that the Gibbs free energy, delta G is equal to delta H minus T into delta S. T into delta S. So the delta G value also depends on delta H and delta S. When delta H and delta S are negative, delta G also becomes negative at low temperature. So, sir, during adsorption, delta H is also negative, sir. Delta S is also negative, sir. Delta G is also negative. Sir, option should be C, sir. Option should be C. Let us check it out. What is the option? Yes, sir. Option C is the answer. Because delta H, delta S, delta G, all of them become negative, sir. What is delta S? Is a state of randomness, we call it as. Delta H is amount of energy liberated during adsorption. Delta G is a Gibbs free energy. Next one. And the same thing, if you can go through it. During adsorption, I told you, no? Delta S is always negative, sir. The randomness decreases. And during adsorption, small amount of heat is liberated. That means delta H is also negative. Delta H is also negative. At low temperature, even delta G also becomes negative. Next one. I'll just clear this. Pair of metals purified by Van Arkel method is. So what is this Van Arkel method? We call it as a vapor phase refining. So what is a vapor phase refining? So in this, there are two methods. Which are the two methods? One is Mond's method and other is Van Arkel method. What is the basis of all this method? The metal to be purified, that is impure metal, is made to react with some chemical and converted into what? Vapors by heating it at very high temperature. And again, these vapors is heated at much more higher temperature. What will happen? Then it will decompose to give what? Metal. pure metal plus impure. Yes. So now metal and the impurity are separated. You get a pure metal. And this method we call it as a vapor phase refining. In that we use two methods. One is Mond's method and Van Arkel method. So what is the answer for this? Whether we use silver and gold? No, sir. Silver and gold, we don't do it by this method. It's zirconium and titanium, sir. Zirconium and titanium. We do it by which method? Van Arkel method. Remember this one. In a Mond's method, we usually do it for nickel. What we do? We treat it with carbonyl. It become a vapors and highly unstable. Nickel carbonyl. Again, we heat it at much more air temperature and we end up getting purity. Same way, we can do it for zirconium and titanium, but that method is called as Van Arkel method. Where what we do? We treat with chemical like iodine. You get a unstable compound, which is a vapor. Again, by heating it at much more higher temperature, again decompose to give a pure metal. So the answer is zirconium and titanium. Next one. The noble gas which does not occur in the atmosphere is the noble gas which does not occur in the atmosphere is. And remember, most of these noble gas, in fact, we isolate it from atmosphere only. But one gas is there, which we cannot get it from atmosphere. First one, radon. So radon no madakagudilla atmosphere. Then question number 9 is from D&F block. And I told you, question number 8 and 18 is always from noble gas. P block in the, but P block nare yav question in yav group in the 18th group in the. Remember this one. There are two questions in P block in MCQ. Both the questions will be from noble gases. So you can easily study noble gases, you get 2 marks just in MCQ. Now coming to D&F block. The 9th question always belongs to D&F block. The element which does not show variable oxygen state is. What would be the answer? We know that all these things belong to what? So they all belong to D block. And D block elements are what? Sir, transition elements. And they have variable oxygen state. But the question is that only. One which does not have variable oxygen state is. So the first one is the answer. Why, sir? Why it's like this? Why you get variable oxygen state? You get variable oxygen state because you take electron from both S and D block. From S, you get 2 electrons. And from D block, unpaired electron 5, you get, so totally you may get 7 electron. Means you can have an oxygen state of +7, +2 to +7. For example, manganese. So manganese can have an oxygen state from +2 to +7. That's why we say variable oxygen state. But scandium does not have. Why? What is scandium? Atomic number is, sir, 21. And if I write the electronic configuration, what it will be? Sir, argon is having 20 electrons, 18 electrons. So if I write 4s2, and it becomes 3d1. 3d1. So scandium you can remove one electron. It can easily have +3 oxidation state by counting the electron present in 4s2 and 3d1. But after this, it's not possible. After this is not possible. Why? Sir, you're reaching a noble gas configuration. After removing one electron, you're reaching a noble gas configuration. And it is highly stable. You need more energy to remove the electron. So it is not possible. So scandium shows only one oxidation state, that is +3. There's no variable oxidation state in scandium. So the option is A only, sir, scandium. Because after removing the electrons in this particular 3D and 4s, it reaches a stable state. An example of ambidextrant ligand is what is ambidextrant, sir? You know that ligand can be monodentate. What is monodentate? It can give one pair of electron. Gives one pair of electron. Like that bidentate, tridentate, and also ambidentate. So what is ambidentate? Ambident as two domain. As a two domain for donating electron. But at any time, at any given time, it gives only one pair of electron. At any given time, give only one pair of electron. So it is like a monodentate. One pair of electron. Even though it is having a 2 electron donating site, it behaves like a monodentate. But it can use both the domains. But once if it uses one domain, it will not use other domain. That's what is called ambident. Example, cyanide salt. Either it can donate from this particular nitrogen, also from this cyanide, carbon. That we call it as an ambidentate. They have a 2 donating site, but there is only one at any given time. We call it as ambidentate. Remember this one. Next one. So primary alkali prefer to undergo which kind of reaction? He says primary alkali. And we know that alkalides undergo nucleophilic substitution reaction. So they undergo nucleophilic substitution reaction. When you say substitution, it cannot be condensation, it cannot be addition reaction. So it has to be, sir, nucleophilic substitution first order, nucleophilic substitution second order. Which one it will be? So it cannot be SN1 also. Why, sir? Because SN1, here intermediate, it's a 2-step reaction. And the intermediate is carbocation. Intermediate is carbocation. And when you take carbocation, among the carbocation, tertiary carbocation is more stable than secondary and primary. Secondary and primary. So in this case, tertiary alkali are more preferred than secondary and primary. So it cannot be SN1. So what is remaining? SN2. Why SN2, sir? It is a one-step reaction. And here, there is no intermediate. The reaction is through transition state. And here, nucleophile should approach easily. Nucleophile should approach easily. And to approach easily, should approach easily. And nucleophile, if it has to approach the carbon atom, there should be less steric endurance. Less steric endurance. And that is possible, sir, only in a primary. So primary alkaloid is more prone towards SN1 than tertiary, sir. So which is the primary? SN2, sir. Answer is SN2. Next one. When phenol is treated with excess of bromine water, it gives what? What is this reaction? Sir, phenol, first you remember in words. It's nothing but ESR reaction. What is ESR? Sir, electrophilic substitution reaction. What will happen when phenol reacts with bromine? There are two kinds of reactions. Bromine. I write it here. So if phenol reacts with bromine water, it gives you 2,4,6 tribromophene. If it reacts with bromine in CS2, in carbon disulfide, it gives you ortho and para bromine. Even position 2, 4, 6 is nothing but ortho. 2 is ortho, 6 is ortho, 4 is para only. So whenever phenol undergoes ESR reaction, when phenol gives ESR reaction, the product is always ortho and para, which is the position of ortho, 2 and 6, plus para. What is para? The fourth position. So it will never go to meta. What is meta? Meta is the third position. So this is not possible. So it is not possible. Then 2,4 dibromo. Di substitute product is not possible. Either you get tri-substituted, either you get monosubstituted, and disubstituted is not possible. So A and C is not the answer. Answer is B and D. But B is only when you take bromine in CS2. When it is bromine in water, it has to be D is the answer. Take a screenshot if you want. If I write the reaction, it is like this. Phenol, no? This is phenol. And what you are having, OH group you are having. That place is taken as 1. This is 2, 3, 4, 5, 6. At 2, 4, 6, this is the position of ortho and para. This is ortho. The position of 4 is called as para. Everywhere you get bromine. Why? The OH group is highly activating. Then you have to say, so OH group is highly activating. Highly activating, sir. Activating group always gives orthoparaproduct. They always give ortho and paraproduct. Right. Take a screenshot. And question number 12 is always from the alcohol chapter. Remember this. In Clemenson's reduction, the carbonic compound is treated with dash to form corresponding hydrocarbon. I told you in aldehydes ketones, there are 4 kinds of reduction is there. Don't miss it. Which are the 4 reduction? I told you. So Rosenman reduction. Then Stephen's reduction. Then Clemenson's. Last one is Wolff-Kishner reduction. Kishner. So he says already Clemenson's reduction. What is Clemenson's reduction? So Clemenson's reduction is all about converting aldehydes and ketones into hydrocarbons. By using what? Sir, zinc amalgam means with mercury and Sc. What is the option then? Sir, it should be the E options. You can make your own notes. One small notes I told you now to make notes. Make a chota notes. Rosenman reduction, which is the reducing agent? Palladium, sir. Stephen's reduction was stannous chloride and HCl. Clemenson's was zinc amalgam and HCl. Wolff-Kishner, I told you, hydrazine plus glycol in KOH. Like this, you can make a note. It becomes easy to remember. So answer should be sir, zinc amalgam and HCl. Next one. Among the following, the strongest base in aqueous medium is? What may be the strongest base in aqueous medium? This is from chapter organic compounds containing nitrogen. Amines. I told you, their basic nature is very important. So basic nature of amines is very, very important. What is basic nature? Amine act as a Lewis base. Amine is a Lewis base. Means they donate pair of electron. And I told you, there are 2 things. In a gaseous medium, I told you already, tertiary is more stable, more basic than secondary and primary. Because here, only plus psi effect is important. Where in a gaseous phase. When you go to aqueous phase, there, the basic nature depends on 3 things. Of course, depends on inductive effect, depends on steric effect, depends on hydration, solvation. It's a combination of all these 3 factors which decides basic nature. Then in that condition, secondary becomes more basic than primary, becomes more basic than tertiary, more basic than ammonia, I told you. Which is the secondary? I told you, if NH2 is there, there's a primary. NH2 is there means it's a primary. So this cannot be possible. A and D cannot be possible. So only option is C and B. But B is N is there. N means tertiary. So it cannot be possible. Only option is C options are, that is secondary in nature. Take a screenshot. Next one. So let us check it out. Yes, sir. Option is C. So what we have done is right. Starch is a polymer of what? These are very simple in nature. Just what you have to do is that in a biomolecules, you have to make a one chart. In biomolecules, you have to make a chart. What chart? Whatever is you studied now, that's why I told you, whatever you study, say for example, you studied about sucrose, and sucrose is made up of what? You know that, oh, it is made up of alpha glucose plus beta fructose. A small chart. Then, what is the linkage? Oh, C1 to C2. Then lactose, like that. Made up of what? Oh, beta galactose plus alpha glucose or beta glucose. What is the linkage? C1 to C2. Then one more is there, maltose. Maltose is made up of what? Sir, they are made up of only alpha glucose plus alpha glucose. What is the linkage? So this is C1 to C4. This is also C1 to C4. Then let us take starch. Starch is made up of what? Alpha glucose. And what is the linkage? In this, both C1 to C4 is there, C1 to C6 is also there. Where in a component called as amylopectin. Starch has two components. Whereas in amylose, it is also made up of alpha glucose. But the linkage is only C1 to C4. Where, sir? Sir, in amylose. Then cellulose. Sir, what is cellulose is made up of? Cellulose is made up of beta glucose, sir. What is the linkage? Sir, C1 to C4. Like that, glycogen. So that is also made up of what? Alpha glucose. What is the linkage? Sir, both C1 to C4 will be there and C1 to C6. Like this, whatever you study, just make a one chart, simple chart. Make a one table like this. You can enter curves, you can recall. What is the question? Starch is a polymer. You can see starch, it has two components, amylose and amylopectin. Both are made up of what? Sir, alpha glucose. What is alpha glucose? Where it is? Sir, D cannot be fructose. Fructose, beta. Answer is yes, sir. Next one. Fill in the blanks. In that first question, 16 question is always from solution. And here in this fill in the blanks, what is happening here is that he'll give us option. So it becomes very easy. It becomes very easy. Dash in nitrogen gas is an example of gaseous solution, is asking. In solution, we know that gaseous solution, solid solution, liquid solution we are having. Here, gaseous solution means this camphor is taken in a nitrogen gas. That becomes a, sir, gaseous solution. Next one. Fill in the blanks. Question number 17 is always from chemical kinetics. In a first order reaction, the concentration of the reaction decreases dash with time. How it decreases? So it decreases exponentially with time. A word kotinodi. Illi the word. So he has given word this. So in word match agar nodi. It cannot match. Very simple. It cannot match. Already camper use ಮಾಡ್ಬಿಟ್ಟಿದ್ದೀನಿ. ಅಲ್ಲಿ ಆ ವರ್ಡಿಗೆ ಡಿಕ್ರೀಸಸ್ ಆ ವರ್ಡಿಗೆ ಯೂಸ್ ಆಗೋದು ಯಾವುದು ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲಿ ವಿತ್ ಟೈಮ್. ಸೊ next one. So fill in the blanks again. And remember, you already used exponentially, you already used camper. You cannot use this one. You're left with only three things. The first noble gas compound was prepared by reacting xenon wave. Say, imagine you are not able to answer it. Simply imagine you're not able to answer it. Let us keep it like that. We'll go to 19. What is the question number 19? Very simple. Poisonous gas is formed when chloroform is exposed to air and light. When you say chloroform, you know the formula, CaCl3. That means it belongs to chapter alloalkanes and allorenes. And chloroform, you know that is an anesthetic. Very long back, they use it as anesthetic. But when it undergoes oxidation, it forms a compound called as COCl2. That is poisonous gas. Phosgene. So the answer is phosgene, sir. Phosgene. So you're left with only two things. Let's go to next question number. So answer is phosgene. The main constituent detal are chloroxylenol. Detal means, you know, the chapter is chemistry in everyday life. One is chloroxylenol and terpineol. Camper used, exponentially used, phosgene used. You're left with only two options, terpineol. If terpineol comes here, then for this question number, we left no one. For that answer should be PTF6. What is that? Here is the question. Question number 18. And I told you, always in MCQ, the question 8 and 18, they come from P block. And in P block, which group? It is always from 18th group, sir. Noble gas. From noble gas only, they will ask you the question. Since I've used exponentially, I've used camper, I've used terpineol, I've used phosgene. What is the answer? Sir, PTS. Easily you can make out. That's why I told you, MCQ has made your job very easy. Very easy. Very good. Shejade, Mariam, very good. Raim Sheikh, you are given for question number 20, PTF6. It cannot be. I told you, no. This is for 18. Sometimes not to worry. Even if you don't know, look at here. What I've done, by understanding the 4 other questions, I got an answer for this one. Because since I've used all the 4, what is remaining? PTF6. That should be the answer for this one. Anikesh, are you there?
Yes, sir.
Yeah. Can we take a break? No?
Sir, we'll take a 15 minutes break, sir.
Yeah, right. Thank you then. Huh?
Yes, sir.
You'll tell the students?
Yes, sir.
Yeah, right.
Students, we'll have 15 minutes break. Please join by 6:05, and we'll start another session again for the same chemistry. And any doubts you have, you can ask me, and you can just ask in the QA box.
What do you think a good university should have to give you lifelong learning experiences?
That's a good question.
A good university should have
worldwide recognition program,
innovative pedagogy and interdisciplinary teaching approach,
best-in-class faculties with industry exposure,
modern state-of-the-art infrastructure,
advanced lab facilities,
and wide industrial exposure for outstanding placements.
Dayanand Sagar University, a beacon of inspiration, quality, and wisdom. With a legacy spanning over 6 decades, the university is known as the Pride of South Bangalore. Consistently rated as one of the top 3 universities in Karnataka, Dayanand Sagar University inspires students with unique perspectives and knowledge. And now, to inspire thousands more, the university expands its in-demand programs to the Kudlu Gate City Innovation Campus. Equipped with world-class infrastructure, industry-driven innovation laboratories, on-campus medical facilities, and multifaceted faculties, creating a whole new world of possibilities for the brilliant minds in the heart of Bangalore city.
The best thing about this campus is that it is easily accessible. It only takes 45 minutes for me to reach here from Indranagar. Some of my friends come here from Hosur and Whitefield.
DSU City Innovation Campus is so well placed that everyone in the city would love to access it.
The City Innovation Campus now offers coveted programs in commerce, management, arts, design, humanities, computing applications, law, and basic and applied sciences to help students explore the unexplored and discover new possibilities.
This part of the city has always been missing a prestigious campus with these courses, but now with DSU this will be solved. DSU is the synonym of trust. The university employs industry experts and easily attracts national and international collaborations.
Due to its proximity to the IT hub of Bangalore, DSU is a hotbed for placements and industrial exposure, and also the preferred places for companies to set up the incubation centers.
experiential learning or practical learning is right at the forefront of things when it comes to student activities.
The relaxed and cohesive environment attained through an engaging, innovative, and industry-aligned curriculum, a technology-driven campus, and innovation laboratories ingrain confidence in students to grab exceptional career opportunities, exemplifying the university's position as a premium university in placements.
In summary, Dayanand Sagar University offers facilities for the overall development, and I request the students to come and explore the opportunities.
DSU persuades us to aim big and to live dreams, and dreams are the most powerful energy. The values instilled at DSU will stay with us forever, and this is how I discovered my career should be.
Come, be a part of this journey to etch the bright future of the next generation. Dayanand Sagar University, live the dream.
Ravi sir.
Anikesh?
Yes, sir. We'll start, sir.
Yeah, 2-3 minutes.
Okay, sir. Okay.
Yeah, students, let them come.
Okay, sir.
Anikesh?
Yes, sir. So we'll start.
Yeah.
I guess, sir, half of students have joined and some are remaining. They'll be joining soon, sir. We have dropped them messages also.
No, no problem.
Yes, sir.
We'll wait for 1 or 2 minutes. They are
Okay,
coming
sir.
now. Yeah, they are
Yes, sir.
joining. No problem. We'll wait for 2 minutes.
After the session, please share all these PDFs and PPTs because students they are asking for all the PDFs and PPTs which are done in the sessions.
Anikesh? Anikesh? Anikesh?
Yes, sir.
Shall we start?
Yes, sir. We'll start now, sir.
Yeah, right. Is it audible, Anikesh? No? Is it clear?
Yes, sir. It's audible.
Okay. So, dear students, come back again to our Minds Spark series. So, last class ಅಲ್ಲಿ ನಿಮಗೆ MCQ ನ ಡಿಸ್ಕಸ್ ಮಾಡಿದೆ ಅಲ್ವಾ? So, now we will go to questions. First, 2 marks questions ನ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೀನಿ. ಎಷ್ಟು ಕ್ವಶನ್ಸ್ ನೀವು ಆನ್ಸರ್ ಮಾಡಬೇಕು? Only 4 questions you have to answer. Okay. What I am telling you is that, and always one more thing. ಈ MCQ ನೆಲ್ಲ ನೀವೇನ್ ಮಾಡಬೇಕು? ಮೊದಲನೇ ಫಸ್ಟ್ 2 ಅಥವಾ 3 ಪೇಜ್ ನ ಬರೆದ್ಬಿಡಿ. Please remember this one, very important. I forgotten to tell you. What is that, sir? All MCQ means, sir, first 20 question. MCQ plus fill in the blanks. So totally how many questions? 20 questions. Andre 20 marks ನಿಮಗೆ. 20 questions ನ, my dear students, ನಿಮಗೆ ಆನ್ಸರ್ ಶೀಟ್ ಅನ್ಕೋಣ. ಫಸ್ಟ್ ಪೇಜ್ ಇದು ಫಸ್ಟ್ ಪೇಜ್, ಇದು ಸೆಕೆಂಡ್ ಪೇಜ್. Don't worry, sir. It will be empty. No, not to worry. Leave it empty. Say this is the line present on the answer sheet. And here you will write 1 answer. You will write something. 2 you will write. 3 you will write. 4, 5, 6, 7, 8, 9, 10, 11, 12. So 15 you don't know. Imagine 16 you don't know. Leave it gap. No problem. Leave a gap. 17 you don't know. Leave a gap. Nothing will happen. 18 you don't know. Leave a gap. So come to third page. Third page you come. In the third page again, please properly you put your question number. 19 you don't know. 20 you don't know. Leave it gap. Nothing will happen. Say you know only 1, 2, 3, 4. You know you have written it. You don't know answer for all these things. Leave a gap. Nobody will question you. You start from here. Part 2. You start from here. You just put a 1 line. Put here. Say after some time you remember some answer for this 16. Write it down. At last, I told you, you have to do revisal of this paper. Last few minutes when it is there. Say, write the answer. If you don't know what are the answer, write it down. Nothing will happen. And nobody will question you why you left blank. And these questions, don't write anything anywhere else. First 20 question, write it in first 2 or 3 pages only. And don't repeat it. Say, first question, option A. Then after around a few pages, again you write the first question, answer B. And don't think they will take a right answer. No. First option, MCQ, first option will be considered. If it is wrong only. Second option will not be considered. So don't write anywhere else. Next one. So give any 2 differences between crystalline and amorphous solid. I told you, this question is mainly from solids only. Any question they may ask you. Difference between Schottky and Frenkel defect. Difference between N-type semiconductor and P-type semiconductor. Just 2 marks means just write 2 points. Don't write all the cock and bull stories. Just you have to write it 2 points. Any 2 points. Say I will give you. So this is the answer. Very simple one. Actually, very simple one. What is that? So they have a definite shape, the over. They have a irregular shape. Enough. They have a sharp melting point. They don't have a sharp melting. Enough, that is. So two difference enough? More than enough. More than enough. If you know other things also, please write down. So crystalline are anisotropic, whereas amorphous are isotropic. This is for crystalline. And this for amorphous. Amorphous. Please take a screenshot. All the differences, no, you make a one list. So what are the differences? Starting from this chapter. So crystal and amorphous, Schottky and Frenkel defect, Sir N-type and P-type semiconductor, Sir ideal and non-ideal solution. All the differences like this: positive deviation, positive non-ideal solution, and negative non-ideal solution. Like this, all the differences till last 16 chapter. Okay, please don't forget. Probably the last chapter, chemistry there. What is the difference? So difference between soaps and detergents. In polymers, thermosetting and thermoplastic. Thermoplastic. All these differences only, you make one list that itself becomes one notes, beautiful notes. During exam, you can revise it. So next, we'll go to one more question. The conductivity of a 0.20 molar solution of KCl at 298 Kelvin is 0.0248 Siemens per centimeter. Calculate its molar conductivity. Calculate its molar conductivity. This is just for 2 marks. A very simple question it is. So rounds answer it. I told you in electrochemistry, this question is always from electrochemistry. I told you numericals will appear either on Faraday's first law and second law, either on Nernst equation, either on, I told you, conductivity, molar conductivity, or equivalent conductivity. A very simple question they will ask you. Then I told you about Kohlrausch's law. This one you have to remember. What is molar conductivity? Sir, conductivity due to 1 mole of electrolyte. 1 mole of an electrolyte. One mole of an electrolyte. What is equivalent conductivity? Conductivity due to 1 gram equivalent weight of a substance. Here we have to take gram molecular weight. Gram molecular weight, 1 mole, sir. What is the formula? Sir, molar conductivity is equal to 1000 into K. What is K? So this is nothing but specific conductance. Divided by, what is C? Sir, C is concentration. C is concentration. What is K? Kappa. We call it a specific conductance. The specific conductance, they are given, sir, how much? Sir, 0.0248. And molar conductivity means, I told you, gram molecular weight. Gram molecular weight means molarity. What is the molarity? Sir, 0.20 molar. Molar. So when you simplify it, how much we get? 124 Simon centimeter square per mole. And don't write anything else. Only this much you have to write. Nothing else. So what you have to do when the numericals are given like this, immediately you start with your answer and just write given data. So what is given data? You write on kappa. is equal to what? So 0.0248 Simon per centimeter over. What else are they given? So they're given concentration. What is the concentration they're given? 0.20 molar. Then what is the formula? This is the formula. Then substitution. Remember, formula, substitution. Then value with units. Very important. Units illa andre mass kodadilla. Value with units. So remember this 4 component in any numericals. Write given data, write the formula, then substitute it and simplify. Write the value with units, very, very important. So these 4 components you should remember in any numerical, because each of these will have a step, marks. Each of these steps will have a marks. So don't miss it. Define molecularity. For a zero reaction, will the molecularity be equal to 0? First of all, then you have to remember what is the order and molecularity. What is molecularity? It is nothing but number of molecules of reactant. So number of molecules of reactant where in a balanced chemical equation, in a balanced elementary reaction. Equation. So what is the order? Order is all about what? Sum of the powers. Sum of the powers of what? Rate equation. Powers of concentration term. Sum of the powers of concentration term. Concentration term. Where? In rate equation of a reaction. Equation of a reaction. This can be 0 or fraction also. Order can be 0 or fraction. But molecularity is always a whole number. Whole number. When you say whole number, it cannot be 0. So it cannot be 0. No need to write all these things. You just have to write what is given for molecularity. For your understanding, I told both the things. You have to explain only molecularity. What is molecularity? So it is the number of molecules of a reactant in a balanced chemical equation. Over. And it is always a whole number. And it is calculated by elementary equation. Elementary reaction or equation. But this is order is determined by experiment. This is determined by experiment. So molecularity cannot be 0. Molecularity cannot be 0. This much answer is enough. Don't write, I told you no. All the story. Just write 2 points. 1 point and 2 points. Over. They give 2 marks for it. And question number 23 is always from chemical kinetics. Always from chemical kinetics. Next. So what is a lanthanide contraction? Mention any one of its consequences. We have studied in where? D and F block. Sir, in F block, we have discussed about this lanthanide contraction. The steady decrease in atomic and ionic size along the lanthanide series with increase in atomic number is known as lanthanide contraction. First point. Mention any one of its consequences. Because of consequences, because of this contraction, what is happening? Because of this atomic size of the second and third transition series is having a similar in size. And when they're having similar size, separation is becoming difficult. This is not required. But you remember, why it is happening? Because we know that there is an imperfect shielding of one electron by another in 4f subshell. So is it required? Not required. Not required. Don't write all the story. Only to the point. What are the questions they are given? Only that much you write. If you want to understand, I will tell you. Why this happens, sir? When we say imperfect shielding, we call it as what? Screening effect also. Some students, they refer it as screening effect. Sir, what will happen to screening effect? Screening effect is more in S. As you go towards F, sir, it decreases. As the imperfect effect decreases, means screening effect decreases. Shielding effect decreases. When shielding effect decreases, what will happen is that Z effect, effective nuclear charge increases. Effective nuclear charge. What is that? The ability of a nucleus to attract electron. So the attraction between nucleus and electron and nucleus and electron, sir, increases. And this leads to what? Contraction. We call it as a lanthanide contraction. If it happens in a 5f subshell, we call it as an actinide contraction. This is the reason for it. This is the cause for it. But he's not asking all these things. Don't write all these stories. This is only for your understanding. Just write this much, nothing else. Next one we'll go to. So what is the composition of a Lucas reagent and what is the inference observed when tertiary alcohol is treated with Lucas reagent? Is treated with Lucas reagent. Where we study this? So this study in an alcohol chapter. Say in an alcohol, where you study this one? You have to recall like that. Sir, if you take alcohol, in alcohol there are only 3 preparations are there. Look at here. How to make a short notes, I'll tell you like this. Alcohol. What are the preparation? You can prepare by using Grignard reagent or MgX. One method. You can also prepare alcohol by using what? By using hydrocarbon. There's another method. So we can also prepare it from carbonyl compounds. Means aldehyde ketones. So these are the 3 methods what we are having. Then what are the reaction? The reactions are either cleavage of OH group, we call it as. Cleavage of OH group. Means you're breaking this bond. Either you are having cleavage of CO group. Cleavage of CO group, we call it as. You're breaking this bond. Either you are having reaction due to both OH and R group. Little bit of you have to discuss about methanol and ethanol. Only this much you have to study. You have to make a short note like this. Then it becomes easy to study. Now our question, where it comes here. Cleavage of OH. What are the things you study? It comes here. Cleavage of CO group. In cleavage of OH group, what you study? You study reaction with sodium here. You study reaction, acidic nature of a alcohol. You study esterification here. You study acetylation here. And here, our topic now comes here. Cleavage of CO group. Here, we study about reaction with HCl. So we study reaction with HCl. Reaction with PCl5. Reaction with SOCl2. All this reaction we study. So definitely, the Lucas reaction with Lucas reagent comes here. What is Lucas reagent? Sir, Lucas reagent is nothing but mixture of anhydrous zinc chloride with HCl. What will happen? When alcohol reacts with this particular HCl, what will happen? So these H and Cl, the H and the Cl, H and OH, the OH and the H combine to form what? Because which bond is breaking? I just redo it. It becomes easy for you. I will take one alcohol with carbon atom also. Or imagine CH2OH is there. It becomes easy for you to understand now. Yes, here is it. What will happen? So the CO bond breaks here. This bond breaks here. The OH and H combine to form water, sir. Plus what is remaining? Sir, RCH2Cl. And this is the precipitate, a kind of a white precipitate. And that we say cloudiness. Cloudiness appears in the test tube. Or we say turbidity appears in the test tube. Appears in the test tube. If this alcohol is tertiary, you don't need a reagent, a catalyst. Zinc chloride is not required. Because here, tertiary alcohol is more reactive than secondary, more reactive than primary. But for primary alcohol, if it is not tertiary, if it is a primary alcohol, you require zinc chloride. So the turbidity appears due to formation of RCl, means alkyl halide. It is nothing but a cleavage of CO group. So what is asking? What is the composition of Lucas reagent? So the composition of Lucas reagent is nothing but what? HCl and anhydrous zinc chloride. So you have to write it like this. Answer. So the first part, HCl and zinc chloride. The second part, he says, what is the interference observed in tertiary alcohol is treated with Lucas reagent? What you have to write? Don't write all these things. The table I have given only for your reference. What you have to write? Tertiary alcohol reacts with Lucas reagent easily. And turbidity, cloudiness is formed immediately. He's asking what is the inference? Very simple. Turbidity appears immediately. So turbidity appears immediately. Immediately. Where? In tertiary alcohol. No need to write other stories. These things are primary alcohol, what will happen, secondary alcohol, what will happen. No need to write. This entire table is not required. Just I given for your inference. Only this much you have to write. The composition of Lucas reagent is HCl and anhydrous zinc chloride. He will give you 1 marks. Turbidity appears immediately. He will give you 1 marks. Over. You get 2 marks for it. Explain Yell-Vollard-Zelinsky reaction. Where we get it? I told you in carboxylic acid. Very important is. Sir, you tell me 2 things which are very important. Acidic nature. You have to study about acidic nature of carboxylic acid. Practice a lot. Carboxylic acid is acidic in nature. It is acid. What kind of acid? So it is a strong acid. Electron withdrawing group. increases acidic nature, all these things. With all the example, you please study. Don't forget, increases. So that is not our topic. That's not our topic. Why I told you is that one more important topic is I told you HZ reaction, L-Vollard-Zelinsky reaction. And it is very simple. What is that? Alpha hydrogen in carboxylic acid is replaced by halogen. That's it. By halogen in presence of phosphorus is known as L-Vollard-Zelinsky reaction. So what is alpha hydrogen? Let us take one example. CH3COOH with chlorine. Here, the COH is the functional group. And the carbon next to it is called as alpha carbon. And the hydrogen attached to alpha carbon is called as alpha hydrogen. That's it. What will happen? When you carry out the reaction, one of the hydrogen, alpha hydrogen replaced by chlorine, you get chloroacetic acid. And this kind of reaction is known as L-Vollard-Zelinsky reaction. This reaction takes place in presence of phosphorus. So in carboxylic acid, this two topic is important. Acidic nature and L-Vollard-Zelinsky reaction. You can just write the general definition also. You can give one example also, no problem. You can write anything. Here I have taken just one general example. This is the alpha hydrogen, and the alpha hydrogen is replaced by one halogen in presence of a phosphorus. This kind of reaction is known as L-Vollard-Zelinsky reaction. Please remember this one. What are food preservatives? Give an example. And always question number 27 is from Chemistry in Everyday Life. What is a food preservative? Very simple. Chemical which prevent rancidity of food or spoilage of food are called as food preservative. That's it. Just you have to write one example. There are many examples we have discussed in books. Very common example is sodium benzoate. Sodium benzoate. Even salt can be preservative. Even propionate salts can be preservative. Salts of propionic acid is a preservative. There are many preservatives there, but sodium benzoate is a very popular one. Just write 2 points. And don't write too many examples. Just any one example. The chemical substance which prevent the spoilage of food. Any one example. Sodium benzoate. That's enough. This is a very popular food preservative. In the same way, instead of food preservative, you can also ask what are meant by antioxidants. This is also a very popular question. What is antioxidant? Which are the popular question in this chapter? Antioxidants, antacids, analgesics, then antifertility. These are very common question they ask in this chapter. Just remember one keyword, antioxidant. They simply prevent the spoilage. They also prevent spoilage of food. Spoilage of food. By what? Sir, by oxidation. That's why they're called as antioxidant. They also prevent spoilage of food by oxidation. Sir, antacid prevent acidity. Sir, analgesic reduces pain. Antifertility prevents pregnancy. Just remember like this. Keyword in each category. Easily you can finish this chapter. Next one. So explain saponification with an example. Explain saponification with an example. This is not electrochemistry. This is chemistry in everyday life. Remember this one. So chemistry in everyday life. I told you, no, there will be 5 marks for this chapter. Where you get 5 marks? The 2 marks here only. Question number 27 and 28 are the 2 marks. And 1 MCQ. So totally 5 marks. Very simple chapter, very easy to explain it. Saponification. The process of forming a soap is known as saponification. Over. Process of forming soap. Forming soap is known as saponification. What is soap? How we get it? Very simple. Sir, oils and fats are treated with alkali. Treated with alkali, like NaOH. Then we get sodium salt of fatty acid. Salt of fatty acid. Plus glycerol. And this sodium salt of fatty acid is also known as what? Soap. And the process is known as saponification. And the process is known as saponification. And he says with example. He says with example. You can take any example. Oils and fats. For example, I will take stearic acid. Or we can take tristearate. So tristearate is a fat, tristearate, made up of stearic acid. Let us add NaOH. What do you get? You get sodium stearate. Sodium stearate. Plus you get glycerol. And sodium stearate is known as soap. That process is known as saponification. And we can write it in the form of an equation also. Like this also we can write. So what is saponification? When oils and fats are treated with NaOH, you get a soap. The process is known as saponification. It's called saponification. What is the example? I told you, tristearate. This is a tristearate. When you treat it with sodium hydroxide, you get what? Sodium stearate plus glycerol. That's enough. So remember, this is a chemistry in everyday life. Last topic. In chemistry in everyday life, at last, you study about soaps and detergents. Soaps and detergents. There we discuss about these things. Next we'll go. So this is question number 28. This is mainly, remember this one. We are coming to part 4, component 4. This is part C. And each question carries 3 marks. You'll be having 8 questions, but you have to write only 4. And each question carries 3 marks. And this chapter is from General Principles and Isolation of Elements. Isolation of elements. Andre, generally we call it as a metallurgy ಅಂತ ಕರಿತೀವಿ. He says, write the reactions involved in the process of leaching of bauxite ore. Leaching of bauxite ore. So what is this leaching of bauxite ore? What is this leaching? So where we have studied, that you have to remember first. Oh, this we have studied in concentration of ore. Concentration of ore. That is the one steps in during extraction of metal. First step is what? Crushing and grinding. When we take the ore from the earth, we crush and grind it. Then we do concentration of ore. What is concentration of ore? It is all about removal of impurity. It is all about removal of impurity. What are the methods we study? You have studied about flotation method. You study about, say, magnetic separation. Then you study about gravity separation. And the last one is leaching. Leaching. And usually leaching, we do it for aluminum ore. What is aluminum ore? Bauxite. That is what the topic is all about. That is the topic. So what we have to do? We have to take the bauxite, and that bauxite has to be treated with what? Sir, sodium hydroxide solution. When this happens, impurity and the metal, they get separated based on differences in solubility. Impurity and metal is separated based on solubility in NaOH. Solubility in NaOH. And all the aluminum, they get solubilized to form sodium aluminate. So this is how it takes place. When the powdered ore is treated with NaOH, all the impurities remains insoluble. Aluminum forms a sodium aluminate. Sodium aluminate. So what will happen? The impurities are insoluble. So impurity is insoluble. We take sodium aluminate solution. We take this sodium aluminate solution and then we treat it with carbon dioxide and little bit of hydrated aluminum oxide is added. Then all the aluminum will be precipitated as alumina. Will precipitate as alumina. That's what we require. Alumina. What we have to do now? Just take the alumina and heat it a little bit. And we end up getting pure alumina. We end up getting pure alumina. Pure bauxite. Alumina is nothing but pure bauxite. So these three steps you have to remember. What are the three steps? So in first step, we treat with NaOH solution. It forms a sodium aluminate, which is soluble. Remember, which is soluble. This is soluble component. Plus you get impurities which are insoluble. So by filtration, we can throw out the impurity, collect the sodium aluminate and treat it with carbon dioxide and little bit of hydrated aluminum oxide. We end up getting hydrated alumina. So we end up getting hydrated alumina. And by heating hydrated alumina, we get pure alumina, that is pure bauxite. So this process of removing impurity from the ore is called as what? Concentration of concentration. Otherly, leaching is one of the methods. Leaching is one of the methods. Please just write this much, you have to write it down. And each step carries 1 marks. Sir has to give one, they have to give 3 marks to you then. Write the optimum condition to get ammonia by Haber process. What are the optimum conditions to get ammonia by Weber process? Just you have to mention the conditions. And always question number 30 belongs to PUC. How many marks? 3 marks. I told you, it is all about any one of the question. Either it is the manufacture of ammonia, or the manufacture of nitric acid, or the manufacture of sulfuric. Any one of the question definitely will ask. Remember this one. How to obtain from Weber process? In Weber process, what will happen? Nitrogen, sir, combines with hydrogen to form ammonia. How many moles you take? 2 moles. That means here you have to take 3 moles of hydrogen. And here, delta H is equal to negative. Negative means what? Sir, it's the exothermic reaction. So for this reaction, we have to tell the optimum condition. This reaction takes place in terms of iron. Iron is a catalyst here. What are the condition? Then we have to look for Leach-Taylor principle. Sir, by using Leach-Taylor principle, where we studied in a chemical equilibrium, we have studied. This will help us to find out the suitable condition. Okay. So what are the suitable conditions? So these are the suitable conditions. Since it is a exothermic reaction, exothermic means negative. Heat is liberated. Have to maintain low temperature. So I go for 700 Kelvin. Because if I take low temperature, reaction becomes slow. So I will not take too less. I take optimum of 700 Kelvin. And pressure, it should be less or more pressure. It has to be more pressure. Why? According to Leach-Taylor principle, more the pressure, equilibrium will shift towards less number of moles. Less number of moles. What do you mean by that? That means, you look at it. Your reactant, you are having 4 moles, 3 plus 1. And product, you are having 2 moles. What you need is forward reaction. If forward reaction has to take place, you should go towards 2 moles, means less number of moles. To go towards less number of moles, equilibrium should shift towards right side. And for that, pressure should be more. So you have to take 200 atmosphere. And since iron is the catalyst here, and for that promoter is a K2O or L2O, they act as a promoter. Means they increase the efficiency of a catalyst. So they increase the efficiency of a catalyst. So this much you have to write. Whatever I written in writing is only for your understanding. Don't write all those things. Only these things you have to write. Nothing else. Next one. So next question number 31 is also from P block. Give an example for each basic oxide and neutral oxide. What happens when SO2 is passed through aqueous solution of iron 3? What is iron 3? Ferric salt. They call it as a ferric salt. So ferric salt. What is a basic oxide? Remember this one. Metallic oxides are always basic. Metallic oxides are always basic. So non-metallic oxides are acidic. We don't want acidic. So what we need is a neutral oxides. So what we can take? So we can take metallic. Metallic means what? Magnesium is a very good metal. So magnesium oxides are basic. Like that, copper is a metal. So they're basic. So this is for the first part, part A. Neutral oxides. N2 or dinitrogen oxides are basic, neutral. Carbon monoxides are neutral. Let us come to part B. What is part B? What happens when SO2 passes through ferric salt? Ferric means +3, I told you. What SO2 will do? Will reduce it. Reduce it. What do you mean by reduce it? That means it gives electron. And electron carry what charge? Minus charge. +3 minus becomes +2, sir. That means it becomes ferrous. Ferrous. That means SO2 reduces ferric ions into ferrous. So ferric salt into ferrous salt, sir. That's it. Only this much you have to write down. Take a screenshot. And don't write anything else. Whatever they have asked, only that much. A and this is B. Your answer should always be like this. Left-hand side of the margin is like this in the answer paper. And the left-hand side of the margin, you write it down. 31A, B. Explain the bleaching action of chlorine water and name the halogen which forms only one oxoacids. We know that chlorine water, we use it for what? We use it for washing, swimming pool, to clean the swimming pool. Is it not? Why this chlorinated water has the ability to kill pathogens? It has the ability to kill pathogens. Why it is like that? What makes it to act as a, what we call it as a disinfectant? It can have the ability to kill pathogens. Why it is like this? It is like because, sir, it is mainly due to oxidation, sir. What will happen? When chlorine reacts with water, it forms HCl and O. What is this O? This we call it as a nascent oxygen. We call it as a nascent oxygen. And nascent oxygen is highly active. And that has the ability to kill pathogen. And also why we use it as a bleaching agent here. He is not asking for bleaching action. Means it removes the stain. It removes stain because the colored substance reacts with this oxygen to form a colorless substance. And that's why the chlorine water is used in the bleaching action. So take a screenshot. This is for option A. Answer 32A. Next we'll go part B. What is the part B? So this is part A. Name the halogen which forms only one oxoacids. That is this one, part B, sir. Which is the answer? So fluorine, because of its small size, and there is no d orbital. Next, calculate the spin-only magnetic momentum of M3 plus ion and tell us why scandium 3 plus is colorless. Give reason. Give reason. Again, question number 33 is always from D&F block. And all these things very easily we can calculate. Calculate spin-only magnetic momentum. What is the formula for this? We know that mu is equal to square root of n into n plus 2. So what is n? N is equal to, sir, number of unpaired electrons. Number of unpaired electrons. Unpaired electrons. That we call it as a n. So how to calculate n? We have to write the configuration. We have to write the configuration for it. M3 plus he says, and atomic number is Z27. So what we have to do? That means it has lost 3 electrons. We have to write 3. How much we get? So we get 24. That means for 24, we have to write M plus 3 means it is having 24 electrons. We have to write argon. It is having 18 electron. 4s2, 20. Then sir 3d4. What is 34? 3d4 means in 3d we are having a 5 suborbitals, sir. 1, 2, 3, 4, 5. And you have 4 electrons. 1, 2, 3, 4. So here n is equal to 4, sir. N is equal to 4. So when n is equal to 4, so what I got? Sir, n is equal to 4. 4 into 4 plus 2. Mu is equal to what? Square root of 24. That is 4.8 in Bohr's magneton answer. What is the Z configuration? Sir, Z is 27, he says. What is 27? We have to write it like this. Argon sub 4s2, that is 20, and 3d7. First, you have to remove the electron from S. From S. When you remove the electron from S and 1 from 7. So what is the configuration? 4s0 it becomes, and it becomes 3d6. So n is equal to how much? 4, sir. So 4.8 in BM. This is the option A. Option A. Then he says in option B, why scandium 3 plus is colorless? Is colorless. Let us study about scandium. So scandium atomic number is 21. So what is the configuration? Sir, argon 18. And if you take 4s, it becomes 2, 20. And this is 3d1. You say scandium 3 plus. 3 plus means you have lost 3 electrons. Your last 3 electron means it has to be 18. 18 means, so it is only argon 18. Argon 18 means it's a noble gas configuration. Noble gas. Means there is no unpaired electron. No unpaired electron. When there is no unpaired electron, there is no DD transition. No DD transition means electron cannot jump from one d orbital to another d orbital. When they cannot jump, they cannot give color. So scandium 3 plus is colorless. Just you can write it like this. So due to the absence of unpaired d electron, scandium is colorless. So this is part A and this is part B. How is pure potassium dichromate manufactured by using chromate ore? Again, DNDF block. So remember, in this part C, I told you, okay, all these three questions, look at here, are from DNDF block. How is pure potassium dichromate is manufactured from chromate ore? Just 3 steps are there. If you write that 3 steps, you get 3 marks. You get 3 marks. What is the first step? Remember, you are using chromite ore and treating with sodium carbonate, and you get what? Sodium chromate. This is the first step. So getting sodium chromate is the first step. What are the next steps, sir? The sodium chromate is acidified with sulfuric acid. You get what? Sir, you get sodium dichromate. This is the second step. Sodium dichromate is treated with KCl salt, and you end up getting potassium dichromate. So first step is obtaining a sodium chromate. Second step is chromate to dichromate. Third step is from sodium to potassium dichromate. So these are the 3 steps you have to remember. And all the 3 steps will have 1 marks each. So we get a 3 marks here. And remember all this formula. Chromate is FeCr2O4. Sodium chromate is Na2CrO4. Dichromate is CrO4 becomes Cr2O7. Potassium means only sodium is replaced by K. Potassium dichromate. So just you have to remember the path. What is the path? First is sodium chromate we have to get. Then sodium dichromate. Next, potassium dichromate. What are you using? Sir, I'm using sodium carbonate. I'm using sulfuric acid. I'm using KCl. This is a must question. Don't miss it. Okay. Either you may ask potassium dichromate, or instead of this, you can ask potassium permanganate also. You can ask KMnO4. Next question. This question is from coordination. What are the answer? Just tell me what may be the answer. What may be the answer for it? What are the things we have to tell? So we have to tell about hybridization first. Then we have to tell the shape of the molecule, structure, and also magnetic property. These things I have to tell. What is the complex? So it's a nickel complex, which is the ligand. Halogen is the ligand, and halogens are, remember, is a weak ligand. Is a weak ligand. How many marks? 3 marks. Why 3 marks? Each mark is for telling the hybridization, structure, and magnetic. That's it. And you know that nickel. So what is the atomic number of nickel? Here I have written the configuration.
Sir, you're on mute, sir.
Okay.
Yeah, sir, from the no question only, then no one was able to hear you.
Che. Is it audible now?
Yes, sir, it's audible now, sir.
So here, what is happening here? Here, the chlorine is a weak ligand. So pairing is not possible. So I end up taking 4p orbital. What are 4p? There are 3 orbitals. Are there px, py, pz? According to valence band theory, VBT, I need a vacant orbitals to undergo hybridization. They are the one which undergo hybridization. And nickel has to combine with 4 chlorine atoms. So I need 4 houses, 4 vacant orbitals. And they undergo what hybridization? Sir, sp3 hybridization. And they give me 4 sp3 hybrid orbitals. And 4 chlorine gives 4 pair of electron that will be filled in this sp3 hybrid orbitals. So hybridization is sp3. Then the shape is tetrahedral. So how many electrons I'm having? All are paired, but 2 unpaired electrons are there. So it is paramagnetic. So these will carry 3 marks for you. Next one. Draw the energy level diagram to show splitting of degenerated orbital in a crystal field theory. Write the type of isomerism exhibited by coordinate complex having ambient ligands. Before this question, in 35 question, no, I want to tell you one more thing. Please remember this valence band theory. There are 3 theories we have to study here in coordination compounds. Which are the 3 theories? First is Werner theory. Then one more is VBT. Then other one is crystal field theory. Don't miss it. Any 2 will appearing intermittently. They're appearing. This is, that this is a compulsory question. VBT is. Sometimes if you have a advantage, you may get this CFT theory also. Both may come also. Don't miss it. All this theory and their postulates, very important. Okay. What are the postulates of Werner band theory, valence band theory? Please remember. What are the postulates of valence band theory? Important things you should remember. And postulates of crystal field theory. Postulates of Werner theory. Don't miss it. Don't miss it. Just make a note of it. Few points. Keywords, you write it down. Draw the energy level diagram to show splitting of degenerated orbitals. Okay. In an octahedral crystal field. Octahedral crystal. So how to write down? Just now I told you, crystal field theory. What is the crystal field theory? According to this theory, all d orbitals are degenerative. What is degenerative? Degenerative means they have same energy. So they have a same energy. What will happen? Upon approach of ligand, they split. They split into 2 energy levels. Yes. And these 2 energy level is known as what? EG and T2G. And that's what he's asking. He's just asking diagram, nothing else. No need to write down all these things. He's just asking diagram. What is the diagram? First, all the d orbitals. How many d orbitals? 5. So they're having the same energy. And they split into 2 energy levels. Which are those? low energy level is known as T2G, and the unstable one is known as EG, higher energy level. In a low energy level, sir, you are having 3 d orbitals. In an upper energy level, you are having 2 d orbitals. These are dxy, dyz, and dzx. And these are ds square minus y square, dz square. The difference between these two energy level is known as delta O. That is called as crystal field splitting energy of an octahedral complex. This diagram, no, you this what you have to write down. Just write the diagram, nothing else. And if you add few points, not a problem. But this is a must. You have to write the diagram. Next, what kind of isomerism is exhibited by coordinate complex having an ambident ligands? Sir, ambident means what? I told you already. There were 2 donating sites. But at a given time, they use only one. They form bond through one donating site. They don't use 2. One donating site. So they differ in linkage. So what will happen? They differ in linkage. And that's why they give us to what? Sir, linkage isomerism. Whenever ambident ligand is there, so they give a linkage isomerism. Next one. This is a part D now. We go to 5 marks questions. Calculate the packing efficiency in a simple cubic lattice. This is a compulsory question, you know that one. Instead of simple cubic lattice, we may get phase FCC or BCC. Any one question will appear. This is a compulsory question, you know that one. And also, this question is also very common. They ask for calculation of density of a metal. How many marks? Sir, 2 marks. So it's a 3 plus 2. What is a simple cubic lattice? Let us take it. So this is a simple cubic lattice. And this is the edge length. This is the edge length. What is this edge length? Is called as, sir, A. And here, in this edge length, there are 2 particles are present, and these are the radius of the 2 particles. So A is equal to 2R, and volume of a cubic unit cell is equal to A cube. So it becomes 2R cube or 8R cube. This is one component. And volume of the sphere, each particle is taken as a sphere, is 4 by 3 pi R cube. What is packing efficiency? Volume occupied by one sphere divided by total volume. That is 4 pi R cube by 3 into A cube into 1. This is a simple cubic lattice. And percentage means into 100. How much I get? 52.4%. So this is the packing efficiency of a simple cubic lattice system. Please remember this one. Very important. The formula you have to remember. And what you have to calculate? You have to calculate volume occupied by one sphere. Then total volume of the unit cell that you have. Next one. We have to calculate the density. So what is the given data they're given? They're given atomic mass. They're given the edge length 0.556 nanometer, means 10 to the power of -9 meter. And they told calcium meter. What is the atomic mass of calcium? They given 40. And Avogadro number also they give. So the given data is Z is equal to 4, sir. And A, they are given it then 0.556 nanometer. We are converted into meter, then we are converted into centimeter. Mass of a calcium, 40 grams. And what is the formula? So this is the formula. Z into M by A to the power of 3 and Avogadro number. So what is Z? We know that it's a 4, sir. Because he only says he's a
You're on mute again, sir.
Aniket. Anikesh?
Yes, sir. Yes, sir.
Mute, it is becoming automatically, it is getting muted. See that one?
Sir, are you typing something on the keyboard, sir? Because of that, it might.
Okay.
Yes, sir. Because if you press Alt and A, sir, it will get muted, sir.
Okay, right. And once you substitute, then you have to write the value with the units. So these 4 components should be there in any numericals. Please have it in your mind. Then we'll go to 38 question, and this 38 question will be from chapter solution. Again, 5 marks. Now, how they are distributed? 3 plus 2. I already told you. Usually, the numericals will be from what? Correlative property. Which are the correlative property I told you? First one, relative lowering of vapor pressure. Then, sir, osmotic pressure. Then, elevation in boiling point. Then, sir, elevation, depression in freezing point. In these 4, I told you they will ask you to calculate molar mass of a solute. Or mass of a solute. That's what the question is here. Vapor pressure they are given. And a solution having a 2 gram of a non-volatile solute. So solute how many? 2 grams, sir. 2 grams. Sir, W2. And 78 grams of benzene. What is the vapor pressure of benzene? 195. We have to calculate what? Molar mass of solute we have to calculate. Let us take that problem first. And we know that relative lowering of vapor pressure. P0, vapor pressure of a pure solvent minus vapor pressure of a solution by vapor pressure of a pure solvent. That we call as a relative lowering of vapor pressure, which is proportional to mole fraction. What is mole fraction? Number of moles of A divided by total number of moles of A and B. By using that, we can calculate molar mass of a solute is equal to what? WA into MB divided by WB into relative lowering of vapor pressure. Remember this one. WA and WB are what? These are the weight of the solute and the solvent. Na and B are number of moles of solute and solvent. Remember this one. What is Ma and MB? These are the molecular weight or molecular mass of solute and solvent. So that's what we have to use it. So first, given data. So what is the given data? They're given. So vapor pressure of a pure solvent, they're given. How much it is? So W2 grams. So it is nothing but W2 grams. W is equal to 2 grams. What is 2 grams? That is the solute. Weight of a solvent. Solvent is benzene. How much? So it is 78 grams. What is the vapor pressure of benzene? So P1 is equal to 195. And molar mass of benzene they are given. Sir, M is equal to 78. M1 is equal to 78. So what we have to find out? We have to find out M2. Write the formula. So this is the formula. Substitute all the values. Then simplify. Write the value with units. Gram per mole. Over. So we get a complete marks for it. Let's just clear it. So they may ask sometimes osmotic pressure, sometimes they may give you boiling point, sometimes they may give you depression in freezing point. Now let us go to next question. What is that? So the part B, write the two difference between ideal and non-ideal solution with respect to intermolecular interaction between the components and change in enthalpy. You know the ideal solution, which obeys Raoult's law to all temperature and pressure. Okay. So what is this particular non-ideal solution? Here, AB interaction is not same as AA and BB. Either it will be less or it will be more. Whereas here, in ideal solution, AB interaction is almost near to that of AA and BB. Remember this one. So here, enthalpy of the mixture is equal to 0, but here it is not equal to 0. So why you have taken this difference? Because that's what he says. I have to tell the difference with respect to intermolecular interactions and change in enthalpy. Take a screenshot. Next one. For the given equation, calculate standard cell potential and write the cell representation for the above equation. Name the cathode lead storage battery and write the discharge reaction taking place at cathode. And this chapter, question number 39 is from electrochemistry. You know that one. So how to calculate standard cell potential, E naught? You know that E naught is equal to E naught of a cathode minus E naught of anode. E naught of anode. So, but find out how to find out who is cathode, who is anode. Very simple. Anode is the one where oxidation takes place. Oxidation takes place. Means you give electron. That means you are a very good reducing agent. So anode is the reducing agent. The strong reducing agent become anode. Just remember this part. So among these, who is a very good reducing agent? Very simple. If it is plus and minus, it is easy to make it. If it is plus and minus, it is easy to make. One who is having minus is a strong reducing agent. Who is having my negative SRP value will be a strong reducing agent. One who is having positive will become a strong oxidizing agent. And reducing agent is always an anode that we can make out easily. But problem now is both are having positive value. How to make out? Very simple. Among this positive value, one who is having a lower positive value will become anode because he is near to negative and he becomes a cathode. And while writing this cell, I told you, always anode is written on the left side and cathode is written on the right side. So who is the anode? Copper is the anode. Remember this part. Copper is the anode. Let us calculate the value. How much? Just now I told you. E naught of a cell is equal to what? I told you E naught of a cathode minus or E naught of a anode. Or you can also write right hand electrode minus left hand electrode. Left hand electrode. Who is the anode? Copper is the anode, I told you. And this becomes cathode. So how can I make out anode and cathode? I told you. When both are positive, lesser the positive value will become anode. The more positive value will become cathode. Becomes cathode. So how much I got? 0.46 volts. And I told you, the copper electrode will be present on the left-hand side. And the silver will be present on the right-hand side. So you have taken a copper in a copper sulfate solution, that is 2 plus aqueous. And both are connected by a salt bridge to complete the circuit. So you have to write it like this. Again, silver is in a silver nitrate solution, let us say. So Ag plus, aqueous, and Ag. So these are the answer for the first part, that is part A. Part A. So this will carry 1 marks, this will carry 1 marks, and this will carry 1 marks. Next we'll go to part 2. Name the cathode in the lead storage battery. Name the cathode in the lead storage battery and write the discharge reaction taking place at cathode. So which is the cathode and anode in a lead storage battery? So this is the lead storage battery. You can see that one. The blue one is an anode and the slightly light colored one is a cathode. And the cathode one is having a lead plate packed with lead oxide, is a grid lead packed with lead dioxide. And the blue one, which is an anode, is nothing but a lead. So this is a cathode and this is an anode. So what is the reaction? There the lead oxide reacts with sulfate ions in presence of acid, gains electron to form lead sulfate plus H2. So this is the reaction which is taking place at cathode. Because cathode is the one which accepts electron, anode is the one which donates electron. So just you have to write this one. So this is the part B. No need to write the structure and everything, just I have given for your reference, that's it. Coming to 40, question number 40. Derive the integrated rate equation for the rate constant of a first order reaction. What are the 2 criteria for effective collision according to collision theory? Again, this is another compulsory question. Either you will ask rate constant for first order also, it may ask you for 0 order also. 0 order also. So let us go to first question then. So what is the answer? For a given reaction. So let us take one reaction. What is the given reaction? Any one reaction we will take. R gives rise to product. Reactant gives you product. What is the rate of reaction? So with respect to reactant, the concentration of a reactant decreases. So we write negative dr by dt. Or we can write it as K into molar concentration of reactant. And slightly rearranging, we get dr by r is equal to minus k dt. Integrating both the sides, we get log to the base n r is equal to minus kt plus I, where I is the integration constant. When t is equal to 0, means reaction is not yet started. So concentration of reactant is equal to initial concentration. Substituting these values of R and T in equation 2. Equation 2 means this equation. K is T is 0. So log n R is equal to I. Log n R naught is equal to I. Now let us substitute the value of I again in the equation 2. It becomes log n R is equal to minus KT plus log n R naught. R naught is the initial concentration. We can rearrange it. By rearranging it, we get KT is equal to log n R naught minus log n R. Log A minus B can be written as log A by B. In that way, K is equal to 1 by T log to the base n R naught by R. To convert log to the base n to log to the base 10, you have to multiply it by 2.303. So it becomes K is equal to 2.303 log to the base 10 R naught by R. R naught is the initial concentration, R is a concentration after time T. So this is the rate constant for a first order reaction. First order reaction. Remember this one. This will give us 3 marks. What is the second question then? What are the 2 criteria for effective collision according to collision theory? We know that. What is this one? According to this, if normal reactant collide with each other, we will not get product. No product. Only active reactant and active reactant should collide with each other to form a product. To form a product. And proper orientation of that reactant molecule should be important. And also activation energy. What is activation energy? Reactant who is having enough energy to form a product. That is very, very important. This is the part B. 2 marks, 2 points is enough. Question number 41 is from surface chemistry. He says, give any 2 differences between lyophilic and lyophilic colloids. Explain heterogeneous catalysis with suitable example. Why do colloidal solution exhibit Tyndall effect? And look at the pattern. It is 2 plus 2 plus 1. So first question. Lyophilic and lyophobic. So what is lyophilic? As the name itself says, philic means loving. It is a solvent loving. Phobic means they hate. So they're solvent hating. And these are reversible and irreversible. Lyophilic is stable, whereas lyophobic is less stable. Since they're stable, they cannot be easily coagulated. Since these are unstable, they can be easily coagulated. Not this much, is only 2 points are enough. You write any 2 points is more than enough. Next question. What is heterogeneous catalysis? Heterogeneous means where reactant and product and the catalyst are not in the same place. Say a reactant are gaseous, product is also gaseous, but the catalyst is a solid. We call it as a heterogeneous catalysis. So why do colloidal solution exhibit Tyndall effect? Tyndall effect is all about scattering of light. And to do that, there are two conditions. One condition is that this one. The colloidal particle size should be equal to the wavelength of the light. Roughly equal, or it may be more also, no problem, but should not be less. Second point is that the refractive indices between dispersed phase and dispersion medium should be more. This also you can put. What is that? Refractive indices between dispersed phase and dispersion medium should be more. That is the condition for scattering of light. Discuss SN2 reaction mechanism by taking methyl chloride as an example. Name the organic compound formed when ethyl bromide reacts with the following reagents: alcoholic KNO2, alcoholic AgCl. What is asymmetric carbon? First, we will go for mechanism. Okay. And you know that SN2 reaction, SN2 mechanism takes place in a single step. So it's only one step. So what will happen? The nucleophile OH minus ion attacks the carbon atom from both the sides, from the side opposite to that of chlorine atom. The nucleophile attacks the carbon atom from the opposite to that of chlorine atom. So it forms a transition state. Where CCl bond is partially broken, COH bond is partially formed. And after that, the CCl bond breaks completely to form a methyl alcohol. And this mechanism takes place in a single step. Remember. So this is 2 marks. And then there's one more question for 2 marks. Name the organic compound formed when ethyl bromide reacts with the alcoholic KNO2. He's asking. And alcoholic AgCl. What is ethyl bromide? So C2H5Br is a ethyl bromide. Plus, what will happen? KNO2. There are two kinds of reaction. Either KNO2 or AgNO2. These are the things they ask. And remember, KNO2 is an ionic compound. And AgNO2 is a covalent compound. Always they will ask. Since it's an ionic compound, it's just a NO2 will exchange bromine. That's it. So we'll displace bromine. What do you get? C2H5, NO2 you get. And what is remaining? Sec KBr. You get KBr. In case of AgNO2 is a covalent, so what will happen? Here you get C2H5, ONO you get. Plus, same thing, AgBr. Why is it is happening like this? Because here nitrogen carries lone pair of electron. So ether group forms a bond with nitrogen. So these two, they keep on asking regularly. So in this question paper, he's asking about KNO2. So what do you get? Nitroethane. Nitroethane. Let us see one more thing. AgCl. Same question. Ditto. C2H5Br. They will ask you with KCN also. They ask you with AgCN also. Again, same thing. So KCN is the ionic compound. AgCN is a covalent compound. So what will happen? Sir, CN is the ionic compound. So what will happen? It will displace bromine. Bromine. What is going to happen then? Sir, you get C2H5CN. Cyanide we get. Ethyl cyanide plus Sir KBr. Yes.
So students are saying that it's not AgCl, it's AgNO2. It's not AgNO2, it's AgCl. The last question I guess.
No. What I am telling is that these kind of question will appear. I'll tell you last one. I'll tell you.
Okay.
Yeah, you ask her to put a. Ask her to call me directly. No problem.
Okay, sir. Sir, and one more question is that in VBT we should write spinning or not?
What do you have to write?
In VBT,
Yeah.
we should write spinning or not?
We should write
spinning.
Spelling.
Yes, sir.
Yeah, you have to write. You have to write. But the reaction should be balanced reaction. And look at here. Somebody asked, no, why AgNO2? Because I want to show that these kind of question appears. Of course, it's not AgCN, it's the AgNO2. Usually, either they will give you KNO2, either they will give it to AgNO2. But be ready. If it is KNO2, you get nitroethane. If it is AgNO2, you get what? Ethyl nitrite. Ethyl nitrite. Of course, in this question, he has not asked AgNO2. I just wanted to tell you that, oh, this kind of question can appear. Appears. So this is what you get. Just you have to tell what is asking. Name the organic compound. Just you have to write ethyl nitrate, sir. With alcoholic AgCN, you get ethyl isocyanate. So this is B. And C. What is asymmetric carbon atom? Carbon attached to 4 different groups. Sir, carbon attached to 4 different groups is known as asymmetric. How does ethyl alcohol react with copper at 573 Kelvin? Explain Cope's reaction. Write the IUPAC name up. Ethyl, methyl, ether. Ethyl alcohol reacts with copper at 573. It's nothing but what? It's a dehydrogenation reaction. It's a dehydrogenation. Dehydrogenation reaction. So, what will happen when undergoes this dehydrogenation? What is ethyl alcohol? CH3, CH2, OH. Remove the hydrogen. Say I will remove this hydrogen. What I get? Sir, I end up getting aldehyde, CH3CHO. What kind of aldehyde this is? Sir, I get ethanol plus H2. This is part A. Sir, explain Cope's reaction. What is Cope's reaction? Sir, phenol reacts with NaOH and CO2 to form what? Salicylic acid. Salicylic acid. How to write it down? I'll show you. I'll just clear it. So this is how to write it like this. For the first part here. So part B. What is part B? Cope's reaction. Cope's reaction is like this. I told you what will happen. So phenol reacts with NaOH to form sodium phenate, which again reacts with carbon dioxide at 6 to 7 atmosphere, 413 Kelvin to form salicylic acid. What is ethyl methyl ether? C2H5 OCH3. This is ethyl methyl ether. What is the AUPC name? They are named as, ethers are always named as what? Alkoxyalkane. Named as alkoxyalkane. So this is taken as an alkane. C2H5 group is taken as an alkane. And this part is taken as an alkoxy. So it becomes methoxyethane. Methoxyethane. So that is the last part. This is the part B and this is the part C, methoxyethane. So explain the mechanism of addition of HCN to carbonyl compound. Write the chemical equation of benzaldehyde with acetophenone in presence of dilute alkali at 293 Kelvin. Give the name of major product obtained in the reaction. The pK value of 4-methoxybenzoic acid is greater than 4-nitrobenzoic acid. Which among them is a stronger acid? First, we'll go to mechanism of addition of HCN to carbonyl compound. Addition of HCN to carbonyl. Carbonyl means what? So it may be aldehyde also, ketone also. So what is this reaction? HCN means it's a nucleophile, sir. So it is a nucleophile addition reaction. And that mechanism we have to write. Very simple one. First step, sir, HCN forms a nucleophile CN minus. The CN minus attacks the carbonyl carbon atom. This is the carbonyl carbon atom. This is having plus charge. Minus carbon carbon. To form a tetrahedral intermediate. And this takes one proton from the solution. Takes proton from solution. What is proton? It takes H and O becomes OH. That's it. That we call it as a cyanoid ring. So these three steps, okay, will give us a marks for us. 2 marks will be there for this. Next question. What happens when benzaldehyde reacts with acetophenone? This is what happens. Benzaldehyde combines with acetophenone. In dilute NaOH means it's the aldol condensation. Aldol condensation, sir. Or since these are different molecules, we can also call it as cross aldol condensation. What is cross aldol? Cross aldol means you are having both OH group is there and CO group is there. That's why we call it as a aldol or ketol. After heating, this loses water molecule. From where? Here. I'll take the reading. This OH will be removed and this H will be removed. And we get double bond. This kind of reaction we call it as cross aldol condensation, and the product is benzol acetophenone. Last one. So what about this pK? Very simple. The strength of acid can be measured by K. If K is more or pK is less, that means it's a strong acid. K should be more and pK should be less. He says pK of 4-methoxybenzoic acid is greater. Means pK is more. If pK is more or K is less, that means weak acid. Weaker acid. And who is more strong acid? Sulfur nitrobenzoic acid is stronger. Last question we'll discuss. Explain carbolamine reaction with suitable example. What is carbolamine reaction? We know that one. Formation of isocyanide. When primary amine reacts with chloroform and KOH, it forms a alkyl isocyanide. That is also called as carbolamine. This reaction is called as carbolamine reaction. And this is the example. Methylamine reacts with chloroform and KOH to form what? Methyl isocyanide. What is the second part? Write chemical equation for conversion of nitrobenzene to anodine. What is nitrobenzene? NO2. I have to convert it into NH2, means I have to add hydrogen. Hydrogen means what I have to do? Reduction. By using tin and HCl, it gives you nascent hydrogen. By using nascent hydrogen, nitrobenzene is reduced to anodine. Last one. Write the why primary amines have a higher boiling point than tertiary amines. So this is part B, no? Last one, C. Because primary amines can form more hydrogen bond. Okay. Then tertiary amines. What is primary amine? For example, CH3 and H2. What is tertiary? Means there is no hydrogen at all. So, primary amines can form more hydrogen bond. So, it can form more hydrogen bond. More the hydrogen bond, more the boiling point. Okay. So, dear students, it's already 8 p.m. Okay. So, I've discussed almost around 45 questions. So, I covered all the 5 components. First 2, then 3, that is part C, then 4 and 5 in part D. Remember this one. So 5 marks question we have discussed, 3 marks question we have discussed, 2 marks question we have discussed, and also we have discussed about MCQ and fill in the blanks. If any doubts are there, you can send a message to us. And also, whatever I have discussed, these PDF I'll be sending to Anikesh sir. You can collect from him also. Anikesh, are you there?
Yes, sir.
No? Anything else required,
Yes.
ma?
Sir, the PDFs and also students were asking if there are any more questions for MCQs and in the blanks. So please do share that also for practicing. So it will be easier for students to get to know how the questions will be for chemistry exam.
No problem. No.
Okay. Also, student, thank you, sir. Thank you so much. Session was very good, and students were also active in the session too. We had more than 70 to 80 students. Also, students, so I wish you all the best for your exams, and I know you guys will do well. Also, I would like to inform you that your CET exams date has been announced already. It's 20 and 22nd of May, and we are also starting Learnodaya session. Learnodaya session pre-CET classes after your board exams, and please be in the group itself for upcoming updates for Learnodaya, which is the KCET free programs. And anybody who wishes to join Dayanand Sagar, you have to give DSAT exams. So for registration of DSAT exams, you have to go and register on our website, which is www.edu.dsu.in. in. So I'm typing it in the chat box also. You guys can go there and you can apply for DSAT exam. And also DSU accepts CET, JEE, Comet K and DSAT students also. So you can get admissions easily there. Any other question student you have, you can ask sir these years, and you can also ask if you have any doubt related to exams, how to write your papers, everything you can ask sir also. Yes, Gajendra, you can speak now. Yes, Imlita, I'll send the PDF as soon as possible. Sir will be sending it to me in few minutes, so I'll share it in the group itself. Yes, Gajendra, you want to say something? I will allow you permission to speak. Okay, sir. So we'll end the session here, sir.
Yeah, no problem.
Yes, sir. Thank you, students, for your cooperation. And yesterday it was very misbehavior you did in the group. So I don't want such kind